All right, live on YouTube. And let's see, is Twitch going to come up? I'm live, but it says offline. Okay, there we go. Just had to refresh. All right. So last week, or earlier this week, yeah. So the last thing we did on stream, I fixed the Visible instance counting. And so now this all this actually works right. Well, the frustum culling algorithm is pretty bad, but everything else is fine. And so I'm going to wait to merge this until I actually fix the frustum culling algorithm, maybe do a few other things. Yeah. And so today I want to work on using oriented bounding boxes for culling. And then also in between streams, I fixed some of the build system a bit. So now if I do like a full rebuild, it doesn't take nearly as long. I mean, it still takes a little while, but it doesn't take nearly as long because I'm dynamically linking to SpearV Cross, SpearV Tools, and GL Slang. So now it only compile my code basically, plus like fast GLTF and Vulkan memory allocator. Instead of like recompiling GL Slang and SpearV Cross. So that's an improvement. There we go. Oh yeah, and I want to get rid of, where is it? Here. All right, so not try to individually delete stuff at the end there. And I'm working on a plan to improve all this. Working on a plan to implement ECS instead of just having like this object class. But I'm still working on how exactly I want to do it. And so now I'll leave this alone. But I might even end up getting rid of this memory allocator stuff if I do ECS correctly. So I'm still kind of figuring out how I want to do that off stream. Yeah. So this is great. This works. I just need to fix the culling algorithm. Yeah, and then it's all kind of screwed up. All right. So I have this other branch here for axis aligned bounding box culling. I'm pretty sure it's actually oriented bounding box. Man, I haven't touched this in 5 months. Anyway, yeah, so let's see. I was drawing OBBs, frustum culling. Let me actually just, let me just compare. I don't really care about the pull request. I just want to see the changes. Can this tell me? Yeah, there we go. Right, so I have this shader for actually drawing the bounding boxes. This was for debugging stuff. Whatever. Frustum cull objects. Okay, so here's the actual frustum culling code. Yeah, and so this does take OBBs. Good, and I put links to everything I care about here. So where I actually got all this math from. Yeah, so per object. Okay, that all looks decent. Prefix sum first pass. Yeah. Deuce. ABB. Okay, so this is 2 OBB. Okay. And then I have OBBs. Right, I think the hard part is actually going to be figuring out, not actually, because I'm pretty sure all this code like mostly works. Yeah, the hard part is going to be actually generating the bounding boxes, or not even generating it, but figuring out the memory allocation stuff for it. Yeah, there's buffers. Yeah, so here I'm writing this, and I'm writing the center point and half extents. Okay. to OBB position offset. Yeah. ABB center point. Am I already doing that? Yeah, I think I am. If I go where I'm setting the position or where I'm actually uploading it. Yeah, okay. So I'm calculating the bounding boxes in model. I hope. Yes. Okay, that makes sense. So what this is for is so I have this position offset, and I'm subtracting this from like the actual position I'm setting it, and so this is the center point times the scale. So this AABB, it's the axis line bounding box, so it's just like the box around the model. And so the reason I have to do this is because if I change the scale of a model, then how the transforms affect it changes. Right? So like if I have a model that's at like scale of 10 or something, then it's going to go like 10 times further. But then a lot of these models, they aren't in like some like a normalized scale, right? So like this engine, I have to shrink it down by like 100 times in order to make it reasonably sized. Yeah, and the water bottle is I'm making it 5 times bigger. Yeah, the chessboard is twice as big, right? And so by correcting the position this way, then I actually get the right. So this is actually at like 500 instead of it being like I don't remember exactly how it was, but it was terrible. So yeah, that works great. So I already have some of it, but I just need to be able to upload the oriented bounding boxes to that to the Frostum culling shader. Yeah, object culling data, push constants, box vertices. Okay, and so this is where I'm generating commands. Yeah, so this is for like drawing the. I thought I baked this into the shader. Did I not do it? Where's that box shader? Box vert. Okay, apparently not. That's fine. Yeah, these are just all the vertices for and indices, I guess. Yeah, vertices and indices for drawing boxes. Yeah, and so I have to support line lists. That's fine. Okay, so I'm going to kind of put this into 2 parts. One of them is going to be, yeah, this is all different as well. Okay, one of them is going to be just getting the Frostum culling code to work, and the other one is going to be drawing the bounding boxes. So, I guess just start here, the Frostum cull object shader. And it's not very good. All right, minimize that. So, yeah, or not external, where it's assets, shaders, compute, Frostum pass. Okay. So we've got OBBs. Is this all showing up? Yeah, it's all showing up on screen. Good. Object cull data. Okay, yeah, so I'm not going to be passing the instance data anymore. Yeah, because the OBB, I guess, is already modified by the model matrix. Okay. But then I still have base instance ID. It's like first instance. And then it's its count. I guess so. So that seems fine. Get rid of this. object call data. And then plain frustum. Yep. That's fine. This could be for testing near and far plane. Okay, yeah. And then push constants. I have a frustum and then total object count. Yes, because I'm doing this once per object. Per. Yeah. So before I was doing calling per instance. Now I'm doing it per object. Yeah, that's fine. Ideally do like triangle calling or something, but doing this per object is fine for now. Eventually I can do more fine-grained, but per object should be good enough. And like the bulk of what's actually slowing me down right now is those box models, and those are just one instance anyway. So why having like per instance or even per triangle calling would be a little better is because like if just one instance of a model is in view, then the whole model gets drawn, which is kind of wasteful, but this should be good enough for now. So now we've got object calling data, visibility buffer, and mesh instance IDs. Okay, this is very different. This is frustum call? Yeah, this is frustum call. Okay. Is this before I did? Here's prefix sum first pass. Okay, so yeah, I'm actually adding an extra compute shader. Okay, I see. Since I have to go from objects down to like instances. Yeah, because I'm still doing the prefix sum stuff per instance. Yeah. Okay, that makes sense. So actually, here's what I'm going to do. I'm going to undo all these changes. Yeah. And then I'm going to get rid of its visible and sphere and frustum out of here. And then probably, yeah, basically I just want to make it look like this. So this is total instance count. Push constant, what do I call this? Reduce prefix sum, yeah, get rid of that. It's not frustum const, yeah, because this is just instance count. Instance count. Here we go. Does that even need to be? Yeah, push constant's probably best for that. Like maybe it could be uniform buffer, but this is fine. So, okay, so that's the reduced step. Yeah. So this is what I'm looking at. So I've got total instance count, and we've got, yeah, so now I need the visibility buffer. Okay, so now I'm going to store like, okay, so in here I'm outputting, yeah, I'm going to the visibility buffer. And that's like what this lane active is here. Okay. And visibility buffer of index. Yeah, that makes sense. This could definitely be like 32 times smaller, I think, but I'll figure that out later. Because doing that's a little more complicated. Yeah. So, yeah, I'm just going to copy and paste this, I think. Prefix sum, partial sums, yeah. That seems fine. Okay, that's good. Index, lane active. Right, and then so this is, instead of is visible, this is visibility buffer. And I'll say to do pack visibility buffer. Yeah, it's probably easy to do that. I just have to like yeah, I just have to do like bit shifting stuff. It's like yeah, I think it's like the same kind of way that this works. But anyway. Yeah, the rest of this should be exactly the same. Yep. Okay. So that seems fine. And now I want another compute shader. And this is going to, okay, well, actually, call frustum pass. Yeah, we're going to call this call visibility buffer pass.com. Oh, yeah, there we go. Call visibility buffer. Maybe just get rid of pass. On all these, that's probably a little better. Call visibility buffer. Yeah, reduce prefix sum. Call draws. Okay. And then I can make a file for the actual frustum calling. Frustum call objects. And just copy paste this. Or there we go. So that looks fine. That all looks fine. So constants. Yeah, so this is a little different. So I'm going to call this frustum data or something. Object calling data. Yes, we need the buffer with this. Visibility buffer. Mesh instance IDs. Visibility buffer of mesh instance IDs. Of object base instance ID plus I is an instance count. Yeah. Yeah, so like all this code should work fine because I've tested this, or I think I was drawing them because it was having problems, but it should be like a reasonably performant. And how does this work? Visibility buffer. So yeah, basically I just want to know what the I want to write that yeah, to the visibility buffer. I want to write like that draw command dot first instance plus plus instance count, right? So here, this is for object dot instance count. I mean, should I just pass in the draws instead? Is that better to read from? Instead of trying to do like mesh instance IDs, right? I can just pass in the draw commands and read it from that. Is that good? Object dot base instance ID. Mesh instance IDs of this. Which seems kind of weird. Right. Yeah, so like I've got, so I'm doing this per object. Objects index. And objects is this just this object calling data, which is these oriented bounding boxes. Yeah, so I have one of these per object. Right, but if I pass the draw commands in here, no, it's kind of a problem because I have to match up which draw command goes with which object, and that's not trivial on the GPU, but it is on the CPU. Okay. Yeah, and so this is object.base instance ID plus I. Yeah, so that's instead of base instance ID, or yeah, actually, I think that is what it's called in OpenGL. Instead of vertex index, right? There is something like GL base instance. I think that's where I'm getting that from. And that's actually what I was using before for this, but now it's draw ID. Okay. So would this need to be like object draw ID? Or is it? Yeah, because the thing is, object-based instance ID, right? Like I have multiple instances per object, so. Well, yeah, so the visibility buffer, it needs to follow this instance data, right? And so I need like first instance plus instance count. Yes, but like instance count, like you could have like one object or one instance per object or multiple instances per object. So it's not so simple. Yeah. And okay, yeah, I guess I'm like mapping back from object instance counts or something back to like instance IDs. Okay. Yeah, the other way to do this to make this a little simpler is I could probably do calling for all instances instead of for all objects. But then I have to like rerun this calling code for every instance, which is probably slower than like doing it like this. Yeah, and so these all get visible, right? So I basically what I want to get here is all the instance in IDs for an object. That's what this is, right? For all the instance IDs in the object, set them all to be whatever the visibility flag is. Okay. So then how do I get all the instance IDs for an object? Well, if I go into object, so that should be, it's got something to do with this instances, this thing here, instance alloc pair. Right, and so that is defined in draw, and it has two pieces to it. It has this instance index allocation and this instance data allocation, right? And so I have a vector of these. So this is like the instance data, which is where the model matrix goes, and then this is an index into that data. And like maybe having this extra index here, it slows things down. I would think it'd make it a little, like my thinking is it makes it a little faster for doing calling, but then maybe actually drawing is slower, but it's kind of besides the point. Right, and so I have this index, and then what I need is the offset of it here. So that's what I need, the offset of this instance index. Okay, and I need to get that for all of the so it's something like and this probably won't stay here. This is just instance index alloc in instances, or just call this, I don't know, instance alloc or something, right? And then it's instance alloc dot index offset. Is this divided by size? Yeah, this is divided by size of, or can I just get the size? Dot index dot, or this size, yeah. That should probably be private or protected or something, but whatever. Yeah, so that's fine. Yeah, expression result unused. So that's size t divided by size t. Yeah, and so this should actually be, yeah, this should be 4 since it's like a uint, or yeah, I think they're uints. 32-bit. Yeah, and that's the offset. And so what I need to do is in here, right, I've got this visibility buffer. I've got this object. And then I've got all of these index allocations. So let's just say index offset is this. Right. So I am passing. So yeah, I am passing the instance count here and a base instance ID. All right. So let's say, vector size t, instance offsets, and this is going to be instances dot size. I don't remember if this does reserve or resize, but I'm pretty sure it does resize. So then it makes things annoying. I'm just going to do reserve. Instance offsets dot reserve instances size. There we go. Then I can do instance offsets pushback index offset. So now I've got all these offsets. But now this can be a problem where, like, yeah, if I do like pop and swap or something and I change these offsets around. So this is definitely not completely correct. Maybe there's just, yeah, I'm thinking about it. There might not really be a good way to handle that. Well, anyway, this should work for the moment until I start like deleting things. So I've got all the offsets. Now what? Now I need to upload these to the GPU and just upload it to a certain position wherever, right? So how would this work? I guess I would need a linear allocator on the GPU, and then I just allocate it. Just allocate like the size of this or whatever. Oh no, I would need a linear allocator on top of a linear allocator, I think. Yeah. Right, and so like I have the GPU buffer, and then I have a linear allocator which can allocate multiple blocks of data, and then another linear allocator on top of that which can allocate multiple blocks of data. Yeah, but I would really just need the one per, or no, I just need the one linear. Yeah, I don't need one on top of another. Okay. And then, right, and so let's say I allocate a block of space for these instance offsets on the GPU, and then I need the offset to that, and then that's what I pass into here as like base instance ID. So it wouldn't be base instance ID, it'd be something else, but yeah. And so that's those instance offsets. Yes, that's how I've like mesh instance IDs down here. So what do I want to call this instead of mesh instance IDs? We're just going to call this object instance IDs. I guess so. Yeah. I'll fix all the casing later. Right. And now this is object base instance ID plus I. Yeah, that makes sense. Okay, I can leave that alone. Base instance ID is fine, I guess. Or just say like instance IDs offset, something like that, or instances offset. Yeah, just call it instances offset. Instances offset. Okay, so all I'm really doing is renaming things, but that's fine. Now I'm gonna go to the so in here, I guess when I'm creating an object, I'm gonna need to pass in an allocator for this. Yeah, that's fine. So I guess the object manager can own this. Oh yeah, I managed to get this working. I think like this is fixed in Clang 19. I can probably get. Yeah. I think I have to like change my NICs for like to use the unstable channel, and then I can get Clang 19, and then this error will go away. But anyway, let's just say what did I call this? Object instance IDs. Instance IDs allocator equals new linear allocator on GPU allocator create buffer. This is a buffer usage storage buffer device local host visible. I like to do device local first. Name is the object IDs. Yeah, object instance IDs. Memory property device local host visible. Bitwise operation between different. Oh, memory heap device. No. Property device local host visible. There we go. And then this needs to be a linear allocator on top of the GPU allocation. So kind of like this, except linear instead of contiguous fixed. There we go. And then I just pass that into these objects. So let me get this type, or yeah, this whole thing here. And go to object. Pass that in. I guess I'll have to store it because it needs to free itself later on. Yeah, and I will need some way to update this when there's a reallocation, or when there's like a pop and swap. So that's gonna be tricky to handle. I need to add like callback support or something. I think when I eventually switch over to ECS, this shouldn't be too much of a problem anymore. But for right now, it is kind of a problem. It's not trivial to get it working. Whereas in the ECS thing, it'll just kind of be built in, I think. Not sure yet, because I haven't actually finished designing it. But yeah, that'll probably be next week or later. There we go. And then object instance IDs allocator is object instance IDs allocator. Okay. And then I need the actual allocation. So this is a sub allocation on a, what is it? I have to say it's like a linear allocator and then a GPU allocation. I think that's how that works. Object instance IDs allocation. Yeah. Go object instance IDs allocation equals object instance IDs allocation allocator, allocate byte size is, so these don't actually need to be size t's. These need to be units. Okay. Yeah, byte size will really should just be like instance offsets dot size times size of instance offsets of 0 or something. Yeah, you should have. Yeah, you should definitely have at least one. Yeah, I'm doing reserve anyway. Instances dot size. Yeah. There is some bounds checking thing there, but it's fine. No viable overload equals. So what is the type here that I'm missing? Suballocation, a linear allocator on a GPU allocation pointer. Oh, pointer. There we go. Not sure. Okay, yep, and these are U32Ts now. So that's all good. Yeah. Then I'll just have to write to it. So I'll say, since ID's allocation, write data would be instance offsets.data. And it'll already, yeah, it'll just copy over like byte size from that. So that's good. All right. Fix me. Update this when instance index alloc gets pop and swapped as the last block, something like that. And then in here we can just go, I don't remember, can I just go straight on the allocation, or how does this work? Why can't I? Why isn't anything showing up here? Client's exit. Okay, there we go. I don't know what's going on. Weird. Yeah, so I can't just free it there. I have to free it from the allocation, or the allocator. Yeah, free this thing. There we go. Okay. Is that everything? Except for this part. Yeah, that might be everything actually. That was pretty easy. Okay. Yeah, so we've got object calling data, right? So I still need this. Yeah, so I still need the offset into that buffer. Okay. Yeah, like I need to get this thing's offset. That's fine. And then instance count, that's also fine. Custom total object count. Object calling data, visibility buffer, object instance IDs. Yeah, so I need object calling data and visibility buffer. Visibility buffer is probably pretty easy. I can go over here and see. Yeah, I can create a buffer, but then I think I have to. Yeah, is this thing where like I have to? Yeah, I need to know how much size to give it, so I have to allocate space from it. So I need to know how many instances. So then that I just need to do this match size here with like instance indices. That's fine. What's this called? Visibility buffer. Here, and visibility buffer. Actually, I'll put this up here. There we go. So that's all good. Object instance IDs. That's good. That's good. So now I just need the calling data. Yeah, and the OBBs and all that. So, yeah, object calling data. Then let's make that in the object manager. Or think about how this is going to work first. So I have the offset and the count. Right. So if I go here, object instance IDs allocation, offset. Yeah, and then this needs to be divided by the size. IDs allocation, size. Oh, I do have const size. I should be using that instead. There we go. Yeah. This is, I actually want this to be uint. Instances offset. Let's count as well. Yeah, there we go. 32T instance count equals instances size. Okay. And then, yeah, I have the OBB. And that's the center half extents UVW. Do I use all that? Center half extents UVW. Yep, okay. And does that need, this might need extra padding or something. Yeah, I think I can do scalar block layout now, but let's see. Yeah, padding, okay. So I will put this, yeah, I guess I'll put this in the ABB thing. I think it's in math. Yeah. Okay, that's new AABB. This can actually just be regular AABB. That's fine. Center half extents. Yeah, this is separate. Yeah, that makes sense. So just OBB and then object call data. What does that look like? Call data. Where is this on the? Okay, yeah, I have some padding at the end. Okay. I guess this goes in Object Manager. Sure. Put it here. Base instance ID. So this is instance offset. This is instance count. Yeah, is that what I call it? Or is it instances? Instances offset. Yeah. Maybe I do put this in object. No, because I need it. Yeah, okay, I'll put this in object. Here is fine. So then in Object Manager, I also need to make this. So Object Instance IDs Allocator. So this is the Object Calling Data Allocator. And Object Calling Data. And then this isn't a linear allocator. This is I think this is contiguous fixed. Yes. Yeah, this is contiguous fixed. Yeah. Total object count. Okay. Yeah. And then this gets a size of object call data. looks fine. And then here, contiguous fixed, allocator. And this is object calling data. There we go. And then this also needs to get past object. Yeah, there we go. Not quite sure I did that with Vim, but all right. Because somehow I like copy it without copying the end of the line. I don't know. Because you usually have to like select the whole line and back up or something, but I don't know, whatever. Oh yeah, I think I can do like copy until like, yeah, like there's like skip to the, I forget how it works. Anyway, yeah, grab this. And then paste it there. There we go. Then object calling data allocator. Object calling data allocator. And then object calling data allocator alloc, and this is just a block that goes into object calling data alloc. So this is a suballocation of a contiguous fixed on a GPU allocation pointer. Object calling data alloc. There we go. And then now I have to construct the OBB. Yeah. This count, this offset. Yeah, so let me actually write a function for writing this. Void object write calling data, and then maybe just call this refresh calling data. I'm not sure. So I need the say object call data here. Data whatever. Data dot right. So there's OBB, and then there's instances count, which is this up here. And these should actually always stay the same. Yeah, except this could actually change because of this one up here. Could change because of pop and swap. So that's also not good. So yeah, I'm gonna need to come up with a way to handle like callbacks or something with that. But I probably won't get to that today. I'll have to think about that offline. Okay, and then data OBB. All right, and then yeah, no one's watching anyway. I got to the bathroom. I'll be back in like 5 minutes. So 5-minute break. So to add the function for this, yeah, put it right here. Actually, I'll put it in order. It goes right after scale, apparently. There we go. So now everything works except, yeah, update, pop, and swap. I should probably put a note here as well. Fix me. Oh. Pop, swap update. Yeah. So now OBB. So see how I was doing this. Yeah, well, I think I just have like 2 OBB or something as part of the AABB. I'm saying a lot of letters, but pretty sure it's not too bad. Because yeah, I just have to like multiply the bounding box by the model matrix or something, and then like recalculate the extents. So it's not too bad. Yeah. Cool. Yeah, rotation, scale, center, axis align. Okay, yeah, but then the model owns these, so I probably also have to take these and move them by the centers. Yeah, I have to take this and then like move it by the position. But then do I need to do the position offset? Maybe that's why stuff was broken before. I'm not sure. I feel like I already took care of that at some point. Center point half extents. What? I don't know, I guess I have duplicate stuff everywhere. Okay, yeah, model matrix times. So that's how I get center point half extents. Times mesh AABB. What am I doing with the OBB then? I'm not even using it. Oh, here it is. Here. Model, upload model matrix, update OBB. Right, but I still need to upload this to the GPU. Okay, well, anyway, a bunch of this is probably broken, which is probably why I was having problems with it not working before. So let's just start here. Let's go to math. Here, yep. So I want 2 OBB. Actually, yeah, let's put this here. 2 OBB. Yeah, that's fine to do it like that. Or, yeah, OBB. Oh, yeah, okay, it has to be 2 OBB. These should be cost references. And then right vector, up vector. These come from the camera, I believe. Or what is this? I should probably move these out of camera, but oh yeah, I'm gonna have to move these out of camera because otherwise I'm gonna have problems with like circular dependencies. That works. Let me take these and just put these in common or something. There's no real reason for them to be there. Yeah, put it right here. That looks like a good spot. So just include GLM. There we go. No, type name new ABB and object. It should have got updated when I did the or no, in model. Okay. I probably just have to save this. Yeah. There we go. Okay, probably just save this as well. I'm not sure. Anyway, it goes in object. Yeah, so data OBB. And then got this here. So I got right vector, up vector. These still don't work. I would just need to include I'm in utils. Is it Vulkan utils? I don't even know. Why is this telling me? What? Source utils math. Yeah. Oh, it's renderer Vulkan. Renderer Vulkan common. There we go. Also, I can move this here. There. Now I just need to set prototype. There. So get me the oriented bounding box of this axis align bounding box, given this rotation and scale. Yep, that makes sense. And then I also need to get the stuff for setting the position correctly. Yep. Fix me support animations. Yeah, I think I just need to update the AABB when it's animated to support animations. Yeah, that's all. Oh yeah, and re-upload the object when it's an animated object. Yeah, yeah. So yeah, instead of OBB, let's just say data.obb. And then model. I am storing model, right? No. Reference to non-static member function must be called. There we go. Model ABB center point scale. Yep. Center is position minus offset. Yes, except let's do it like this. Yeah, same thing here. Instance count. Yep. Okay, so that looks good. And then I just want to write the data to the object calling data allocation or alloc write data. There we go. And then I need to free it here. Calling data allocator free on object. Instance IDs or yeah, or no, alloc, there we go. So confusing. No member name free. Oh yeah, because it's like pop and swap. And these actually need to be under model so that it doesn't happen when I'm using the camera. Yeah, it's just kind of messy, and so a bunch of this stuff, whenever I switch to ECS, a bunch of this stuff should get cleaned up. Yeah, so fix me sport animations, fix me pop and swap update. Yeah, that's good. So now I just have to call this really whenever the AABB or the position changes. Yeah, well, I can call it when the position changes here. Yeah. Or, oh, do it like this. Write instance data and then refresh code data. Yeah, so this runs whenever, yeah, once the instance state, once the like position changes, or yeah, I mean, if the if the rotation or scale changes, yeah. So that's good there. And then yeah, the other option. Yeah, but the AABB is not going to change because that's fixed for the model, so that's fine. Yeah, so this is all good. Or, oh yeah, model animation, yeah. But, that's fine. Yeah, model animate. Yeah, I can probably, do like refresh culling data here. If on animate, I also update the AABB. That'd be fine. But for the moment, let's just call this to do because it's not that bad. So now what? Now I need to call the, yeah, I'm calling it. Is that it? So that'll all get uploaded to the GPU here, and OBB center half extents UVW data.obb. Yeah, and then that OBB is padded or whatever, or no, that doesn't make any sense. Where's that coming from? Okay, it is padded. Okay, so that's good. And why something was upset about model and included file? Yeah, okay, it's good now. Is that it for at least this? OBB center half extents UVW object call data offset count. Oh yeah, I need to get the frustum working. Yeah, and the push constants, and then actually run the shader and set up the memory barriers. Yep. So let me set up the shader. Yeah, let me just set up like the buffer. I don't know, whatever. Right, storage buffer here. Right, that's for drawing boxes. That's different. Fix me. Yeah, that's all for boxes. Again, I'm pretty sure that's for boxes. Okay, here we go. This one for set frustum. So yeah, you get this, and this just ends up being a push constant here. And so this comes from the camera. Yeah, so this comes from the camera's projection view matrix. Plane from Vec4. Where's that coming from? I know I copied this code from somewhere, but okay, yeah, here we go. Yeah, I'm blind. Yeah, so do I want to put this in camera? Yeah, I'll probably put this in camera. And I can just have like a camera frustum. Yeah, and that can update like every frame, I think. Proj view. Yeah, this would have to update every frame because the camera's going to move every frame. But then this is just projection view. How is it taking camera position into account? Or this update projection. FOV. Right, like there's projection. And then where's the view matrix? Inverse object matrix. Okay, yep. So yeah, that's going to call it every frame. Whatever. I'll call this like update frustum or something. Just going to be camera update frustum. And then GLM row. Okay. But Proj view, this is like this. I think. Or no, it's underscore. Okay, when I need plane, and then this is going to be frustum planes. This is plane from Vec4, so from Vec4. I didn't change these. Probably because of all the errors. So I need frustum, plane, camera. Yep. Camera. This is public. I think, why I might want this to be private. I mean, basically, whenever I'm setting instance data invalid. Yeah, right. I just kind of want to call update frustum after I set the projection view matrix. Yeah, that's all. So this should be private. Then GLM row and then frust. Where's GLM row coming from? Matrix access? That sounds right. There we go. And then plane and frustum. Where did I define those? Okay, I've got frustum create, but no, that's not quite right. Frustum, cam frustum. Where is it? Here it is. What file is this? Common. Okay. Cool with that. Plane frustum. Yep. Plane P. Okay, just need comment. Actually, I'll put comment in the other file, since I need frustum in the header. Does it need to be like that? I think so. Yes, probably like that. There we go. Yep, so update the frustum, and then I need to get it. So let's say frustum const reference frustum is return frustum. There we go. Yeah, so normal distance. Yeah, that all looks good. So now I need to put this into the push constants for frustum call objects. And that's called frustum data. And I'm doing push constants here, I think. Yeah, set push constant. Yeah, triangle frag. All right, so let's say renderer g set push constant name is frustum data, and yeah, I'll figure that out in a second. So yeah, it says frustum and then total object count. So yeah, I'll just make this a struct. That's fine. Frustum data or something. And this has a frustum f and then uint. Yeah, uint. T. Total object count. Yeah, I want to try to get away from using structs for push constants, but they're much more convenient. And so like I have that weird thing about like doing pointer writer or something, but it's just terrible. So TMP, this is just frustum data, and then frustum data.f equals camera frustum. Yeah, I've already updated projection view matrix, so that's good. And then frustum data total object count. So this is object manager. Do I have a count in here? Object count. Object count. There we go. So that'll update the frustum data. Okay. Now I think I just need to actually run this shader. That should be it for at least this shader. Everything else might be fine. Yeah, so I need to run this and do the memory barriers. Right, and then now the rest of these, so yeah, that's called like instance count, instance count, instance count. So I go back here. Right, and that's triangle frac. So then where else am I doing push constants? Right, yeah, because that didn't change. This one doesn't have any push constants. But where I'm doing that instance count stuff, push constant, writer, yeah, writer, right. Yeah, so this isn't frustum const. This is just instance count, I think. That's what I called it, right? Yeah, instance count. Just write, yeah, the instance count to it. Size, yeah, divided by size of, yeah, that's fine. Yeah, that'll work. Yeah, I mean, I guess I can do the pointer writer thing over in the other one. It's just, it is a little weird. Right, so I can say pointer writer. Yeah, except, yeah, hold on. Just do it. Start here. Pointer writer, renderer, RG, get push constant, frustum data, because this way I'm like writing directly to it, so theoretically it should be slightly faster. Pointer writer, writer, whatever, frustum data. And then get rid of this. Get rid of this. And then frustum data, write cam frustum, and then write the object count. Object manager, object count, yeah, so that's size T, so this has to be 32T. And so that's another thing, right? Like with this frustum data writer, like something like this could really trip you up. So this is definitely not great. But C++ doesn't really have like reflection, so I don't know. Because yeah, ideally I just like reflect yeah, like I do some kind of reflection thing. I don't know. Yeah, maybe I could say so I'm having like pointer, writer, whatever, right? So the push constant, I could just take the hopefully the shader reflection keeps the names and stuff, and then I can just set the name in the push constant. That's probably the best way to do it. Yeah, to do set push constant data by variable name inside the push constant. Yeah, that'd be the best way to do it, I think. Anyway, so that should work. Yeah, and then I'm setting the instance count one. It's right here. Yep, that's good. Then I just need to actually run this. So go, yeah, that will be here. So I need to run this before everything else. Show previous frame vertex read completed before writing. Yeah, so that's actually fine there. So we want to do a compute pass on frustum call objects.comp. And also, this isn't frustum call pass anymore. This is call visibility buffer. Okay. Yeah, I'm probably going to need some specialization data. And some barriers. So what would this be, like compute read write? Yeah. So storage reader, yeah. Compute, or no, previous would be, yeah, I guess read or write. Access to shader storage write bit. So make sure all the shader reads and writes are finished on the compute shader. And then this is for, yeah, I guess this is also read write access on the compute shader. Yeah, so it's just like a compute shader barrier. Okay. That seems good. Yeah, and then I guess just do it again here. There might be a more efficient memory barrier. I'm not sure. Like I know I can do stuff like mark buffers as read only. Yeah. I'm marking this as read only. Yeah, read only, write only. Yeah. Anyway, it's eventually I want to automate memory barriers and synchronization. I'm just kind of thinking ahead a little bit. Anyway, compute pass. Custom call, right? Because like these don't have like read write. Like this is just write and then it's read, or yeah, whatever. This should work. So custom call objects. So do you have any specialization data? So you do local size, but you don't do subgroup size. But it's probably fine anyway because it won't like local. It's still the same order, so it doesn't matter. It just won't actually read it. Yeah, I don't care about subgroup size here. I don't think. No, not really. Okay. So that works. Yeah, so I'm running the shader. I've given it specialization data. I'm running this one. Is this one all good now? I think so. Yeah, and oh yeah, I need to change cold draw. Yeah, some of these names need to change. I updated that. All that still looks good. Cold draws. Yeah, this is fine. Let me go back to renderer, and then it's not. Yeah, so there's cold visibility buffer, right? And then there's a reduce prefix sum, and then it's just cold draws. Okay, I feel like there's something I'm missing. I can try to run it. I would not be surprised if it crashes me, though. Just, I'm sure I missed something. I mean, hopefully it doesn't crash the stream, but yeah, and I'm not doing the, oh, right, group count. Compute pass. Am I not setting group count for these? What? Oh, right, dispatch. Yeah. I just completely skipped over dispatch. So that's something. Dispatch get group count. So this is an instance indices size. This is like object manager or object count, whatever. Do I not have object manager in here? Thought I created. That's annoying. Also, this changes based on the object count. Oh, that's awful. That's... Yeah, now I'm thinking about this. Right, like, oh, yeah. Well, that's why this is a dynamic notice, because this will run every time. Yeah. Okay, that makes sense. But I still need to get the object manager in here somehow. Yeah, so I know how many objects I have. Is there a better way to know how many objects I have? I could do like buffer size. That's probably better anyway. Right, so this is for reading from the objects buffer, from the object culling data buffer. So really, I should be doing the size of this buffer anyway. So this should be GPU allocator, get buffer, check calling data, size, and I just realized, I think it's the same down here, yeah. See, I'm just doing size here. This probably has to be like size divided by 4 or whatever. By GPU allocator, get buffer, object, calling data, size. Yeah, because that's just the, like, this is the byte size of the buffer. Yeah, but I need like the sub allocator size or whatever. Can I say divided by size of? Is there like object call data? Yeah, that works. So yeah, again, this is pretty terrible. But it'll work for now. This should be size of UN32T, I guess. Instance indices. Does this work again? ESPN draw, I guess. Yeah, instance indices. Yeah, these are all UN32Ts. Yeah, so I think I was probably running like 4 times as many that I actually needed. Cold indirect count. Yeah, this is again size of, or wait, no, that's just fill buffer. That's fine. And then this indirect command size divided by size of VK draw index indirect command. Yeah. Yep. So I would not be surprised if things start crashing. But let's go ahead and see if this does anything. Still kind of slow to compile. Probably got something to do with like templates. Okay. Camera. Yep, that makes sense. No matching call to. Okay. Oh, yeah, okay, that makes sense. Yeah, all right, those are easy. What's this? 93, 94, 95 in here. Yep, so these can probably just be like this, right? Up forward, yep. And then object manager, I need to pass. No. What? Object instance ID is calling data. Manager line 20. Oh, right. It's up here. So this is upset. I don't know why, but yeah, that needs to go there. I mean, I guess technically it's probably fine if these aren't above this, but I prefer if they're up there since that depends on it anyway. Okay, that is fine. Or maybe it's just Clang being dumb. I don't know. Let's see how this is. Matching function call for object. Light. Okay, yeah. Where's like add light? Yes. It should be no. It should be like this. And eventually ECS and all this stuff will be like significantly better. But for the moment, it's all objects and it's kind of terrible. Right, I should really just pull that from object, I guess. There we go. And then in here, man, way too many. And then this is object, instance IDs, object, calling data. There we go. Okay. Pipeline layout invalid. Unable to read file frustumcoobjects.com. Why? Oh, right, because base path or whatever. Yes. Base shader path. Let's see if this crashes me. No code generated. Okay. Call visibility buffer, line 30. I probably forgot a semicolon or something. No. Visibility buffer. Oh. That's weird. I don't know how that ever worked. Try to allocate zero-sized buffer. Object instance IDs. Okay, so I forgot to set this one up. Object instance IDs. Oh, yeah, I forgot to set it up. Or is it because it's an object manager? Create buffer, object calling data. Yeah. Yeah, here we go. Object instance IDs. Zero-sized buffer. Why is that happening? Because so that gets called when I go in here into descriptor manager and I run update. Yeah, creating buffers in descriptor update is unsupported, right? But that's it tried to start rendering and then it couldn't find. Or wait, no. This is a different error. Tried to allocate zero-sized buffer. What? Tried to allocate zero-sized buffer, so I tried to call GPU alloc, and I got 0 out of it. How did that even happen? New linear allocator. Object instance IDs allocator. Yeah, and then I create an object. And then I tell it to allocate me a buffer of this size. Times size of UN32T. Instance offsets, instances size. Yeah, this should definitely have instances, right? So this is what I was talking about. I think I said something earlier about 0 instances. Which is kind of weird. Instance offset size. Is it something because I did reserve? No, because I'm doing pushback. 0 instance offset size. Doesn't make any sense. Model path. There we go. Just didn't want to complete it for me. How does box have 0 instance offsets? Right, I'm doing reserve, I'm doing pushback for instance alloc and instances. Yeah. It should have at least 1 instance on the model. I don't understand why this isn't working. Say instances size. Oh, is it because I'm doing like reserve in model? Yeah, it's because I'm doing reserve in model. But I thought I'm doing pushback. I probably just need to use capacity. Yeah, I'm doing reserve and I'm not doing pushback. Yeah, okay, that's why. So this is actually capacity. There we go. That should fix it. I need to come up with like a better solution for handling like so like the problem is that if you do resize with standard vector, it'll create objects, which kind of makes sense. So but then sometimes I don't want it to create stuff, so I just do reserve. But then you run into weird problems with the capacity versus the size, and it's terrible. It's still broke. Why is it still broke? Capacity. Thought that would be it. Capacity 1. Okay, yeah, that makes sense. Why are you 0? The capacity is 1. Oh, right, because I'm doing 4. Yeah. Oh, horrible. Size t I equals 0. I is less than instances capacity plus plus I. Instance index alloc const reference. Instance alloc equals instances of I dot index. Or no, okay. So this is just, what is this stupid thing again? Instance alloc pair. Instance alloc. Reference cannot bind to an L value. Oh, yeah. There we go. That should work. Okay, hopefully I don't crash here. It's taking forever, so maybe I will crash. Yeah, what is it doing? It's taking this long. So, like, this code is super slow? I want to be surprised. But it shouldn't take this long. Because, yeah, it didn't even finish. Yeah. It's weird. Like, it's not rendering yet. Because it would tell me, like, load objects time or something. So, yeah, this stuff could be taking a while, but what I'm actually doing that would take time. Well, no, this is just allocator alloc. Yeah, I'm doing 2 allocator allocs, but I should definitely be able to do these simultaneously. Like there's a mutex log, it's a little slow, but it's not this slow. Let me turn you down to like 10 extra objects. See what that does. Okay, there we go. We created the objects, but it's still stuck. Oh, and cycled. Or there we go. Right or right, of course. Yep. Forgot to take that stuff out. Set for some const. Yeah, this is just gone now. Completely. Yeah, I'm updating that every frame anyway, so I don't need to do that. Don't need to do that. Yeah. So objects really shouldn't have been taking that long to create, but it seems like that's what was going on. Yeah, like even here it's taking a second to do them, which is pretty terrible. Okay, I'm not crashing, which is pretty good. We are... See, I don't know if we're actually calling things, that's the problem. In here I got like 3,000 FPS. I got 3,000 FPS. Yeah, that's why I had those, I was doing those boxes, because before because they would like show up in red and green depending on if I was actually calling things or not. But I can really tell if I have way more objects, but for some reason that's taking way longer than it should. Which again, ECS will fix a lot of this, but okay, so that's like 3,000 and 3,000. So it's still not enough objects to actually cause performance problem. Yeah, it's taken forever. Yeah, it took 1.2 seconds. Like some crazy lock contention or something. I guess so. Okay, here we go. So we got like 2,000 FPS. Okay, so I've got 1,100 FPS, and then I've got 2,000 FPS. But then I know the driver also does its own frustum calling. Maybe, is there any way for me to print out how many draws I actually called? Like called instance count or something? Well, I could take the last, yeah, the last number in the prefix sum should be the number of draws, the number of instances that I have. So yeah, maybe I can just like dump that and we can see what's going on. Yeah, actually, so can I just say, let me go here, down here. Frame rate. Yeah, oh yeah, I want to do timestamp query so that I know how long calling is taking and drawing and all that. But I'll probably do that once I redo the render graph and I go back to like the old, like get rid of all the lambdas. Anyway, so frame rate and then objects post or objects drawn, let's say. So this would be GPU allocator, get buffer, prefix sum, size. Wait, is this right? No, because I want to get like the last. Yeah, so like I'm setting this here. Instance indices, yeah, prefix sum. So yeah, I want to get the data out of this. Prefix sum, is it match? Can I not get data out of this because I don't have an allocation or something stupid like that? Yeah. Well, I can just do this, right? I can say void pointer mapped const return mapped, and this needs to be like a const void pointer or whatever. Yeah, there we go. Mapped. Okay, and then I need to get the size. So we just say, what would this be? This would be a GPU allocation prefix sum buffer equals GPU allocator get buffer prefix sum, and actually this can go like way up here, or yeah, it can go way up here. That's fine. And then say prefix sum buffer mapped. So it's a void pointer, and then I want to get the last one. So I need to like reinterpret this to be a character pointer. Character pointer? Or no. It should be a uint32t pointer. Yep. And then I want to get like the size of it or something. Plus prefix sum buffer size over size of uint32t. That seems right. Right, okay, yeah, and then this is a pointer. Let's just say, what's up here, uint32t. Objects, what can I type? Drawn equals this mess, and I have to like wrap it in a, like I have to dereference this afterwards or something. Yeah, Yeah, so reinterpret cast, then add the size, add the, it should be fine anyway, but yeah, add the size divided by that, and then dereference. No? Reinterpret from const, oh yeah. Const. There we go. Objects drawn. That should work. Hopefully it doesn't crash me. Let's see, this is size divided by, yeah, like if size is 0, yeah, then the size is, well, yeah, size would be like 4. Put me at 1, yeah, I think that makes sense. Hopefully I'm not like reading over and I get, well, yeah, if I'm reading over, I'll segfault instead of like get a GPU hang, so it's not too terrible. Yeah, I definitely wouldn't add like a -1 in there, because then, yeah, like size could be 0, or I don't know, whatever. Yeah, yeah, and this takes forever, so I need to fix this, and it's probably just like lock contention, but still, it shouldn't be this slow, because like, yeah, I probably need to add stuff like pre-allocate. Okay, so drawn is 1074. It's always 1074. Yeah, so the driver is doing stuff. Like the driver is calling for me. That's what it seems like. Right, so if I look at, yeah, let me open this in RenderDoc. I want to speed that up because that's just so bad. Object. So, okay. No, it's probably not the lock contention. It's probably, it has to recreate these buffers every time. So I just need to pre-allocate these buffers. So somewhere I'm doing like pre-allocate stuff. Yeah, I'm doing bulk objects, pre-allocate. Yeah, invalid objects reserve, objects resize. Yeah. Invalid objects reserve, objects resize. Okay, but I'm still not doing like, I'm still not doing like objects like in, or no, I am doing add instance data. Yeah, like where is it? Yeah, it's model pre-allocate here. This is where I'm pre-allocating the instance data slots. Okay. Yeah, and then here I'm running this pre-allocate. So what I probably just need to do is resize object calling data and object instance IDs to be like the number of objects. Or hold on. So object instance IDs. Yeah, that's what I'm allocating from here. That's fine. Yeah, object instance IDs, object calling data. Yeah, so each, okay. So this is a little complicated because, yeah, it's 1 int per instance. So I can get like model instance count or something, I think. Or, yeah, I think I'm keeping track of like total instance count model somewhere. So I can use that. And then here, this is just one of these per object. So if I go in here into pre-allocate, right, so then let's go to GPU allocator, or no, I already have the buffer saved, yeah. So this would be object instance IDs allocator and object calling data allocate. So this, maybe this would need to go into like model pre-allocate, I think so. And then this one, object calling data allocator. So this I need to, why is this so broken? Why is Clang just being completely broken today? Well, Triskin. Object calling data allocator. There we go. Alloc, block size, parent size, pre-allocate. There we go. I want to pre-allocate count of these. That seems good. Pre-allocate works how I think it does, right? So that would be a, right, it's like contiguous fixed. I run pre-allocate, grow size is count minus free blocks size. Yeah, okay, that's good. Okay, and then what about when I go to object instance ID? So this is a linear allocate. Does this have pre-allocate? No, it does not. So I need to add pre-allocate to that. But yeah, even just this should already be a significant speed up. So let me see if that actually makes any sense. Right, so that took like 14 seconds last time. So it should take a lot less than 14 seconds. Yeah, 6.5 seconds. Yeah. Objects drawn is insane number though, so that's something. But I will fix that in RenderDoc in a moment. Yeah, so then the other one, so I need to be able to pre-allocate from this linear allocator. Yeah. So void pre-allocate, that takes a size t const reference count, or byte size. So this kind of needs to do this. Something like this. So yeah, I want to have a block from parent size. Actually, yeah, this might be literally exactly what I need. Yeah, pre-allocate. You just make me a block that's that big. Except instead of block here, this needs to go into the free blocks. Yeah. Or basically, I can just like free this block. Yeah. Make me this big block and then free it, and then when I'm actually going through here, I'll just like keep decrementing the size. So that's good. That should work. And then parent reallocate. Yep. And so now, oh wait, this isn't thread safe. No, this is thread safe actually. Add instance. Okay, so model, doesn't model have like total instance count? Yeah, but it's not public. Or total, yeah, okay. Well, I can make it public. Yeah, I thought I had it up here or something. Size t const reference total instance count is const return underscore total instance data count. Here we go. Object manager. Okay, yeah, because I don't learn. Yeah, so if I'm pre-allocating, yeah, right. I don't need to be multi-threaded because I'm just doing it on the one model. So yeah, so I can say because yeah, when I bulk create, I'm only bulk creating with one model right now at a time. So I can say culling. No, it's instance IDs. Check instance IDs allocator. Pre-allocate. So byte size is going to be model total instance data count times size of win32t. That's good. Yeah, having this fixed size in here is pretty bad, but yeah, other than that, that should work. Okay, so now we should go down from like 6 seconds to 2 seconds. Or less, hopefully less. Still slow. Still 6 seconds, huh? All right, whatever. Yeah, so that's very wrong with objects drawn. So let's try to fix that. So this is reinterpret as prefix sound buffer mapped. Yeah, and even when this gets reallocated, like, Yeah, it's the GPU allocation. So I'm getting the current map. I'm not like, this isn't like VK buffer or something. So that's fine. Yeah, rerun this, get the map, get the size of it, divided by size of uint32t. Yeah, that should be the last thing in the prefix sum buffer. It's probably some stupid off by one error, but yeah. Lots of off by one errors today, or really with this whole project. So run this. This is going to take forever to open now. I'm disappointed in. Yeah, when you give me an absolute nonsense number there, right? And then I look way out here. Let's do this again. And like maybe fly way out a little bit and do it again. So I can just like manually check and see if this is doing anything at all. So, yeah, so 98, 99. I mean, maybe I screwed this up by doing divide. I don't think so, though. Yeah. I think that's fine. Compute shader. Yeah, so visibility buffer. Ugh. Well, that's terrible. It's completely terrible. Or, yeah. Right, it should be like 0 or 1. It shouldn't be this nonsense. 98. Yeah, it should be 1 per instance, which makes sense. Yeah, but none of this is anything even remotely reasonable. Okay, so that's terrible. What does prefix sum look like here? Okay, so this actually ends up being somewhat reasonable. And maybe this is just because I'm setting it Boolean, but it's... Yeah, but this is uints, I don't know, random garbage in the buffer or something. Right, can I look at like the last one? I guess I can make it smaller, and that'll be fine. Yeah. Yeah, dispatch 99. Yeah, and this is 111. Yeah. Am I doing this right? Seems wrong. Yeah, or, yeah, 98 times 64. That still seems wrong. I don't know. Don't save anything. Go back down to like 10 or something. Yeah, let's do 10. Run this. It still takes a while. Yeah, something I'm not even counting is adding like a second. Yeah, objects drawn 1099. I don't even have that many objects. Open this up in render doc. Load it, launch it. Yeah, so that's like everything drawn. And there should be like nothing drawn. Okay, so these are 111. Prefix them. What does this look like? This looks reasonable. Okay, so that's 910. So if I'm saying, yes, a bunch of uints, saying like 910 over 4, or no, I'm saying, whatever, 3644 over 4. Yeah. So I'm not sure why I'm getting a weird number there. I should be getting 911. Yeah, and actually it's not objects drawn, this instance is drawn. Yeah, right, so 3644 over 4 is 911. Yep. Okay, yeah, so that's size 911. Okay. And so I'm probably just reading over it. So size, yeah, so it's this. Yep. Yeah, I knew I needed a -1 somewhere. I just wasn't sure exactly where. So that should be good. So that should give me the correct objects drawn. Yeah, let me just see what that does first. objects drawn as instances drawn. Okay, yeah, there we go. 911, and it doesn't change at all. So I'll call this instances drawn. Okay, now I have to figure out why it's not changing. Just rebuild it. And yeah, I would like to add back my shader that will draw the bounding boxes, and they'll show up in like red and green if I'm drawing them or not. So that's nice. And I mean, ideally how it works now, I should never see like red ones because I think red means not drawing it, but whatever. Load this. Yeah, so everything's visible, nothing's visible. So yeah, that count is 56. So what is my what's my visibility buffer look like? Smaller numbers, but still kind of ridiculous because this shouldn't be units, this should be bools. So maybe that's part of the problem here. Yeah, it's probably basically the problem, I would assume, because everything else looks fine, right? So it's just that visibility buffer is a little screwed up, and it could be that the colon code is broken, or it could be right. But I don't like that this is showing up. Right, so this is bool, but I guess it gets converted to uint anyway. Oh, that's garbage. Or unless if these are uint. No, this is all bool. I hate that. That is terrible. So it's terrible. Yeah, visibility buffer of index. So yeah, this is just like if it's non-zero. So that's not quite right. But like, yeah, I can do memset 0 on it or something. It's just kind of stupid. I would like it to work with bools. Yeah, the other thing I do is like equals 1 or something and make these uints and have it put out 1. And like I kind of get it being uint, right? Like if the GPU, like if it just has to be uint for like alignment reasons, sure, but it should still be reading it as a boolean. Like it should just not care about the extra data. It should just count as like padding. All right, so I look in here. What is the type on this? Visibility buffer is a bunch of uints. Array stride form, yeah. So that's awful. Spear V bool buffer. How does this work? Bool. Boolean type. Scalar. Physical size or bit pattern defined. If they're stored in conjunction with object, they must be with logical addressing operations, not physical, and only with non-externally visible shader storage. Logical addressing operations, not physical. Okay, yeah, and this is a logical operation. So why is this getting converted to uint? Is it like the optimization or something stupid? Did I turn off optimization? I don't even remember if I have it on or off right now. I'm pretty sure it's off. Or on. Yeah, it's on. So let me turn this off. Do not optimize my shaders. Or okay, there's cubes out there, whatever. Probably just look at one of these anyway. So what's going on here? Visibility buffer. Yeah, so it's still uints. That's terrible. I hate that so much. Here the bool buffer converted to uint. Yeah. Pvec. Why? This is so stupid. Just give me booleans. Like SpearV supports it from. I guess I can like mask it or something. Like mask the first bit. Yeah, it's just this is ridiculous. All right, let me just see if I can do some bit manipulation crap here. Visibility buffer index. Yeah, so I need to do and is it that or something? I'm not sure. How do I even? I don't really have much practice with doing like bit level stuff. I mean, that's why this isn't packed, because I have to kind of think about it a little bit. Yeah, like this is broken too, but I guess that's fine. Equals visible bool visible visibility. Am I even using this in here? Or yeah. Right. Here's how I'm writing the visibility buffer. Yeah, if it's visible or not. Yeah. I mean, I could just make it all ints, but it's. So how does this work? 1 shifted over by 32. Yeah, but that's that mask. But I want to get like, hold on. Bit shift get first bit or get last bit or get least significant bit. So it's shifted over 31. Bit 31 becomes bit 0. Just or yeah, just like yeah, I'm trying to just mask it, right? Let's see. Bit mask for least significant bit. FF is a mask. Can I do does that work? No, I don't think so. GLSL hex numbers. Or yeah, I can just do and one. What am I thinking? Yeah. Yeah. I'm way overthinking things. Compilation what? It's a left-hand operand of type bool. A right-hand operand of type. What? Why is it bool here and then so stupid. Okay, fine. This is just gonna be uints, un, I guess. And visibility buffer of index is equal to 1. Whatever. Bool visible. I don't know if I can just set it like that, but we'll see. Yeah, uint visibility buffer. Yeah. Let's see what that does. Cannot convert from temp bool to int. Call frustum objects line 110. Is this a thing? Can I say uint like that? Unexpected right paren. Expecting. Visible. Oh, it's this way. There we go. Okay, well now instances drawn is always 0, so that's something. Yeah, frustum call objects, uint visible. Yeah. It seems reasonable. Yes, we should definitely have instances, but we use 0. So that's not good. Visibility buffer. Does it still look like this? What? Is this stuff wrong? Oh no, like this is the whole buffer. Like none of this is getting set. Like say visible equals false. Right, then that should just wipe out the whole buffer. Because it's a uint buffer. Yeah, am I like setting the size wrong? Visibility buffer, right, so I should have one of these per instance. I'm pretty sure I'm setting it here to be, yeah, number of instance indices. Yeah, make run. Yes, so instances drawn is always 0. Render doc. Launch this. So make it invisible. Why is none of this being set? Let me see what yeah. Geosign spec. Or can I just look for like type conversions or something? Types. Yeah, bool. Integers. Where's like type conversion? Section 541. 54 constructors. Yeah, okay. Converts a Boolean value to an int. Converts a Boolean value to an unsigned integer. Yeah. Constructor bool 0 are used for false, non-zero. When a constructor is used to convert bool to integer, false is 0 and true is 1. Yeah. So why is that all screwed up? I guess it's got something to do with that index buffer being broken. Yeah. So it's got to be this is broken. So let's take a look at that. Oh, can't see all this. So yeah, center, direction W. Okay, look at this. Object instance count, everything is 0. The offsets look not exactly reasonable, but it's something. These are all 0. Why do I have another 0 here? Something updating after deleting? No, I'm not deleting anything. How is it even possible that both of them be 0? A multi-threading thing? Maybe it's a multi-threading thing. Ugh, it's awful. Instances offset. Yeah, well, instance count is all 0, so that's definitely wrong. So let's go on object. Did I like forget to write things? Instance calling data alloc right. Data instance count as instances. Yep. It's capacity. Always something stupid. Offset is instance ID's allocation. Offset divided by size. Yeah, so I don't know how both of these are 0. That doesn't make any sense to me. Unless it's like some weird multi-threading problem, which is certainly possible. I don't know what else it would be. Because it shouldn't be able to give something the same allocation like that. So yeah, so instances drawn is still 0, which actually makes sense because I'm forcing everything off. But render doc should just give me zeros all the way through the buffer now. So let's see what's going on. Compute shader, or not call data. Okay, well, yeah. Right, so now instance counts look reasonable. So that's something. Stability buffer is only sort of reasonable. It's barely reasonable. It's reasonable for not even a single subgroup. Not even a single sub, like, or no, yeah, I guess if we only have 19 objects, no, but I should be for looping. Something's really screwed up here. Objects, object instance count, visibility buffer of offset plus I, object instance IDs, yeah. These other buffers, object instance IDs. Okay, these are all completely screwed up. That's why. Okay, so that's screwed up, and this is sort of screwed up. So how am I getting those object instance IDs again? Instance IDs allocation right. Instance offsets dot data. Index offset. Okay. So objects instance IDs allocation alloc offsets size times size of uint32t. Right. So like this should have the same number of elements as this, I would think, but no, it's way less. 732, and here it's 3644. Oh, man. Instance offsets size times, yeah, and this is 1 per object. Yeah, and this is 1 per instance. Yeah, reserve capacity and then do pushback. Yeah, so size is definitely correct. Probably also do capacity, but whatever. Object instance IDs allocator. So what is this? This is like a linear allocator. Yeah, I would not be surprised if this is some multi-threading problem. Maybe. Yeah, so you want to allocate me a block of that size. Yeah, I'm just gonna, let me just turn off all the threads. Yeah, yeah, turn off all the multi-threading. Run this again, see what I get. Is it anything remotely reasonable? So, yeah, object instance IDs. It still looks like garbage. Yeah, it's still 732. So it's not a multi-threading thing. Yeah. So, what am I actually doing here? instances capacity. Yeah, that's fine. And then I want to reserve enough bytes. Yeah, this is byte size. Enough uints for the number of instance offsets I have, which is the number of instances I have for this specific model. Yeah, that seems completely reasonable. So how is that even possible to be different from the instance count? Right, and then the actual offsets I'm putting in here is the instance alloc. So this comes from instances, right? So this is what I've allocated, and I'm getting the offset divided by the size to get the actual offset number. Yeah, right. But then this. Oh, right. So why these aren't right is I'm not taking first instance into account. Right. Because these index offsets are local to first instance, I think. Right? But then here I need them to be global. I think that's right. So how does this even work? Oh, this is terrible. Terrible. I'm gonna have to like rethink some of this and come back to it later, I guess. Because this is pretty bad. Yeah. Instance indices allocator alloc. Right, because like this happens per draw. So these are just local to the draw call. Yeah. And that's why it was like mesh instance IDs earlier. I mean, the other way to do this is to run this code per instance, which is also not great. Am I in a bad mood? Oh, no, sorry. I'm just a bit tired today, that's all. And getting a little frustrated with this. Yeah, that's all. Yeah, so I'm trying to get frustum calling working, and I'm just having some trouble figuring out how I want to wrangle all of the all the data and stuff. Help you with some C++ homework? Okay. I mean, you can ask me. I'll see what I can do. I won't like give you answers though, but yeah, but you can ask me questions. Assignment: create a uniform distribution, store the result in integer variable. My answer is uniform distribution number int cout. In an integer, store given random difference legend missing. Put new line value check. Legend missing output superfluous output. Ignored output. New line 93 value check 093. Yeah, that's something specific to the auto grader, I think, but it looks like. Yeah, expected output value check. Expected actual output 70 value check 0. It just looks like you're generating the random numbers correctly, but the way you're formatting your output is incorrect. Value is in front. Yeah. Cout number int engine. Well, you just reorder how you're printing things, right? So like if you look here, like I'm doing basically the same kind of thing, right? So like objects and then object count and then frame time and then some more stuff. Like it just seems like you have like the order mixed up here when you're doing this kind of thing. Create a uniform integer distribution between 1 and 100, generate a random number, store the result in an integer variable named number that's already defined. It's weird that they're having you check through like print. Like really how like if I was designing an auto grader, I guess I'd have it work kind of like how like Elite Code or something works, where you just like return the output from the function. You're not doing weird stuff with like checking C out, because that's awful. Um, yeah. Superfluous output, ignored output. Expected output, value check 70, actual output 70, value check 0. Is C out. Yeah, I'm not really sure. Like I think what you want to do is like store that number int engine thing into, yeah, into like a variable somewhere, and then like format the output once you have it as a variable. Something like that. Um yeah, anyway. So object instance IDs, right. So these are local to the draw calls, but I need these to be globals. And how am I actually going to do that? Um, yeah, so this offset here. So this is the calling data. Yeah, and so I think these are right, except there's also the case where two of these are 0, which is also wrong. Um, so yeah, two of these both have an offset of 0, so something's wrong there. But everything else looks fine for these offset values. And then the instance counts are all correct. I don't know what's going on here. All right, and we also have 2 in here twice. I disabled all the multi-threading. So how is that wrong? So this would be object instance IDs allocation. This gets it from the allocator, from the global allocator. So it could be something wrong with my linear allocator library. I think that's the problem. Something wrong with this. Okay. But then other than that, yeah, then the other problem is these need to be global. Or maybe, yeah, that's really annoying. So visibility buffer, object instance IDs of offset plus I. Yeah. So offset plus I of the instance IDs. So maybe for now, I might just switch this around and do it per instance. How bad would that be? Well, I still have to get, right, like right now I'm trying to go from object to instance ID, but then I have to go from instance ID to object. Is that difficult? It's probably less difficult. Yeah, and so the instance IDs is first instance plus, yeah. maybe I could do this a different way. So I have instance count, instance offset, right? So like, yeah, what that offset needs to be is the same thing that first instance is, I think. Yeah, right. I need like first instance and instance count. So I need to get first instance from the draw command. So I would need to tie the draw commands to the objects, and then I can get first instance and instance count from the draw command. Yeah, I think that's the way to do it. Yeah. Right, so how would this work? If I had, say, like I have these, it's in here? Yeah. Just kind of plan out how this might work. Draw command, right? Or if I had a draw command array called draw commands, and then here I can say, so I want to get the draw command for the object. Yes, and then an object can have multiple draw commands, right? So I'm going to say get draw commands for object. And that would be like this or something, right? The object called data, or I don't know, something like that, right? Right, so I get the draw commands for the object. And yeah, I need a count and some other things, but I'm just trying to sketch this out. I don't know if you're still even watching. Yeah, he's gone. Okay. So anyway, I get the draw commands for the object, right? And I can say for uint I0 I listen draw commands count or something. Yes, that's for every draw command, right? And then I want to say for j equals 0, j is less than say draw command equals draw commands of I, and then j is less than draw command dot instance count, and then I want to do this visibility buffer stuff, right? So I want to say visibility buffer of draw command dot first instance plus j. There we go. And then I think that also solves, yeah, that also solves the problem with over here in object. Yes, like there were problems with like pop and swap update, right? But now if I'm getting it directly from the draw command, then this is no longer a problem. So that's good. That simplifies things actually. Okay. So I like this. Yeah. So it's something like this. Yeah, let's get rid of that. Yeah, draw commands. Let's call this object draw commands. Right, and so now what, I would just need a buffer. I don't want to do this. Because like I already have the draw commands buffer. So really this would be like indices or something. Yeah. All right, because I just want to read off that. I don't want to like copy the draw commands. And so I just need something to map the draw command indices in the draw commands buffer to object IDs. Yes. Wait, but hold on. No, this isn't right. No, this is not right. Because this is terrible. Yeah. Because draws can contain multiple instances. I'm definitely gonna have to think about this more. Yeah, this is not right. Because it's not just like draw commands instance count. Yeah, it can't be. I was hoping it would be as simple as that. Yeah, because like then every time I'm setting all the, yeah, like for every object, what that would have done was like for every object, set the visibility for a whole collection of instances for every object. And then like the only culling you'd get is if like whatever the last, or culling or visibility you'd get is like if it's just whatever the last one that decide that like the memory writes get queued up in is actually correct. Yeah, so that would be awful. I can put this back, I think. At the very least. And we can turn optimizations back on because that's not doing anything. We are actually running PN tests, so I'm not going to have problems with like push constants breaking. And that is something I need to fix, is that pointer writer to make it actually work well with push constants instead of just like seg faulting whenever I change things. So visibility buffer. Instances offset. So what I need is all of the, not all the draw calls that an object has, but I need all of the instance IDs, all of the global instance IDs that an object is associated with. That's so maybe put it like this. Uint object global instance IDs, or uint array, right? So this would be like get global instance IDs for object, something like that, right? And then let me just put this up here. Yeah, there we go. And then, yeah, that's not like uint array, but whatever. For uint I equals 0, I is less than. Yeah, I mean, I guess object on instance count is fine. Object instance count plus I. Then I'd say visibility buffer of object global instance IDs of I equals uint visible. Okay. So then what I need is this global instance IDs buffer. And so how I get that is, so I have the instance IDs of the object here, right? Yeah, and so I just need to know like what's like the first, what's the draw that's associated with, Then I can get like the base instance, something like that. Yeah. Hmm. Yeah, otherwise, like, maybe I could just, like, completely change how I'm doing culling and just do, like, triangle culling and, like, skip frustum culling, but I don't know. Probably want both. Yeah, I definitely want both, right? Because I can do frustum culling, and then I can do, like, triangle culling on just, like, the small subset I have left. Yeah, if that's even efficient. Like I know there are efficient ways to do triangle culling, but, like, just the naive algorithm. Well, that's, like, what uh, part of what the vertex shader does anyway, because it'll discard um, off-screen triangles or off-screen like primitive topology, whatever. So yeah, visibility buffer, object instance IDs, instances offset plus I. Yeah, so I need these global instance IDs for an object. That's just someone being loud outside. So get global instance IDs for object. How would I actually get this working? So in an object, I know all the draw calls. Like I can figure out. Yeah, right. Like I can iterate over all of the models, meshes, primitives, and get all the draw calls. And so then I can get all of the first instances. Okay. And then do I just add first instance to like each one of these or something? Yeah, but it's kind of weird. Because like I need to know which instances to add first instance to. But yeah, it's like almost there, right? Like this code. Yeah, so I think this code is almost there. It's just that instead of instead of instances of I like this, right? I want instances of I plus first instance of I or something, right? It's something like that. And then that would all work. And yeah, I'm not sure why I'm getting duplicates here, but that's probably just the linear allocator isn't perfect. Yeah. So how would I get the first instance for instances? Well, so I go in model, right? I go here, instances dot reserve total instance data count. Like so this instance, right? This is instance alloc pair. Maybe I could change this around to actually hold a pointer to the data. So instances has the instance data, the instance index, and then a pointer to the draw command, so that I can like or the draw object, and then I can read the draw command stuff. So that might work. Yeah. Yeah, right, because here's primitive draw at instance. And draw at instance. Yeah, allocators, instance data. Right, so and then this is like instance indices allocator, alloc. Yeah, the other way, the other way. So like I have this instance indices allocator. I don't know. I don't think I ever set this up, but maybe this is a better way of doing it. I can look at this, and I can look at the yeah. I want to put something in here to have it contain a pointer to the allocator. Yeah, the allocator it came from. Or yeah, if this can do realloc, then it has to have. Yeah, it must have a way to see the allocator it came from, right? Do I have like parent or something? Parent is a protected member. Okay. So I could take this instance index alloc and say, hey, give me the parent, and then Yeah, and so the where am I setting first instance? Yeah, it's this thing, parent offset divided by size of uint32t. That might be all I need. Right, so let me see. Yeah, so parent, yeah, but no, because see, parent is like, well, it's hard to show here, but it shows up down there. That it's actually a sub-allocation. It's not this allocator, but is that fine? I think that's fine anyway. Yeah, because this allocator is built on top of a sub-allocation on top of a linear allocator. Yeah, and this is just the offset of the linear allocator. Yeah, instance indices allocator parent. Yeah, these are the same thing. Yeah, so this actually works. Yeah. So we go to object. And yeah, so I have this. I'll say index offset plus equals this, which this is instance alloc. So we just need to get parent or yeah, dot no member name parent and instance alloc pair. Oh, dot index parent offset. There we go. Now parent, I can just have a where is it? Up here? Yeah. I can just get a const reference to parent, and that's fine. Yeah, so this is just parent allocation, t pointer, const. I don't remember like the order for const for pointers. It's always confusing. Anyway, no, not parent. Parent const return parent, and all that's const. Okay. Object parent offset. Hey, there we go. And there's index offset. Right. So add first instance to the offset to make it global. Did you get culling to work yet? Yeah, I don't remember how much you saw the other day. I got frustum culling working, but it's very broken. Right now I'm trying to get and so it was using like the old algorithm, and right now I'm trying to do it with oriented bounding boxes, which is way better. And I might have just figured out how to get it to work. Get rid of that. Yeah, close this. Hopefully this doesn't crash me, but I haven't crashed yet today. So yeah, rebuild all this. Oh yeah, and I changed it around, so rebuilding should be a little faster now because, or actually should be a good bit faster, especially when doing like a full clean build, because I'm dynamically linking to some libraries. Okay, instances drawn 0. So, oh, hey, yeah, I think it's actually working. Okay, some of this is a little broken. I should have like a gear or something here, and it's kind of clipping wrong. Yeah, but I think this is definitely better. Yes, you can see stuff popping in and out, which is not great. So some of the frustum balance are probably not quite right. And I am missing a gear here. But you can see like instances drawn 118, 117, and then like 0. So it's actually working. So like I just got it sort of working. Okay. Now let me add some more of these. 10,000. Let me just settle this back. And so there's some problem also where like somehow some of the code I added is like significantly slowing down the object creation time. So like this will actually take a little while to create these objects. I'm not really sure what's going on with that. Yeah, it took like 6 seconds to make all these. And before it would do it in like 2 seconds. Okay, yeah, so there's definitely some problems. Yeah, I'm gonna profile it. I just haven't got around to it yet. I'm more focused on getting this working. But yeah, I can see like instances drawn 30,000, 10,000, 9,000, 0. Yeah, so we have like 2,000 FPS looking here. Now we got like 5,000 FPS looking away. So definitely making some big improvements. But there's definitely some problems with some of this instance data stuff. Since things are disappearing. So let's go down to like 10 and 10. Yeah, there we go. Yeah, so that's gone, which is not good. All right, but the rest of this seems decent. So, and I think I know what's going, or I'm gonna go ahead and commit this, because this is actually pretty big. I've been working on this for like the last 3 hours. Oh, man. Yeah, basically I want everything except what's in here. Or, you know, yeah, I'll leave this alone. OBB calling slightly broken. Okay, so yeah, first I want to fix, so there's a few things I need to fix. Yeah, or really it says 2 hours, 50 minutes. Yeah, I missed most of the stream. Yeah. A lot of it was me just fumbling around, copy pasting code and figuring out why, like, just kind of get stuck. Yeah, I think I have my schedule down. You should be able to see my schedule. I actually started a little late today, but yeah, anyway, I'll be on for a little while longer. But yeah, most of what I did was just copy over this shader I had from the old engine for doing access aligned bounding box calling, and then just like setting up, just like integrating it into the rest of this engine. So it's just like, it's just kind of like boring boilerplate stuff. And then like what actually has taken 3 hours has been figuring out all the little bugs. Was the old code working at least? Yeah, the old code was mostly working. Actually, I think I can. Yeah, so I just committed. So let me switch to which branch? Because I have like a few branches for the a few branches for this actually. Because there's AABB calling. Oh, I thought I had multiple branches. Okay, never mind. Yeah. So why is this? That's fine. Do not contain CMake list. Oh. Yeah, I need to probably fix this really quick actually. It's because I removed the external dependencies and now they like don't, or maybe I can just do like git submodule update or something. Yeah, there we go. There. Yeah, so now this will take a little while to build, but this will show you the old code. What's going on? Device cannot convert. What? All right, this code is, I don't know, so something's wrong with it. Let me just, yeah, I don't know. But trust me, it kind of works. It did have the same problem of like some things, like the sides of the frustum aren't great. And so one feature I have in this other branch is I have it actually drawing the bounding boxes. And so I'll add that later. Yeah, kind of is good enough, right? So like you saw, like some stuff was kind of getting clipped at the edge, and that's still way better than what I've had before. Yeah, and so in this branch, like the last thing I was working on was trying to fix the algorithm to actually get it correct. Because it's just something like I have the frustum in the wrong size or something. Anyway, yeah, so what I actually want to fix now is you saw some of those models, they were just like completely gone, or some of like the pieces of the models were gone that needed to be there. And so that's what I want to fix now. And then I can fix the algorithm. And also I want to speed it up a bit, or speed up the loading time. So I open this up in render doc. So it'll take a second to load. Okay. Yeah, so like there should be like a gear here and it's not here. You know, it's not on this side either. Yeah, and so like there's that pop in with the triangle at the bottom, and that's normal for this. Yeah. Yeah, and so like I don't think I got animations working correctly, and then like it doesn't support animations, and then some other stuff has just completely disappeared. Yeah. Some weird issues. Like you can see all that like disappears before it actually goes off screen. So there's some problems. But I want to fix this. So if I capture this, and I'm pretty sure what's happening is there's some problem with this object culling data where, yeah, these instance offsets. So I have like duplicate instance offsets. So this is kind of weird how this works. So I'm culling per object right now for custom culling. Except how the rest of my culling code works is it needs to do it per instance because like I need to know eventually like the draws per instance to cull. And so I have this weird thing here where I'm basically trying to convert from object IDs into instance IDs. So then this object instance IDs buffer, this contains like how'd you even call per object if you don't have the transform? I have the oriented bounding box, so like the transform is embedded in this basically. So I'm going over all this object culling data, and so I have the bounding box, and then I have some variables to actually figure out what the instance IDs, what the indices are for the instances or whatever. But it doesn't have to be unique per instance. No, so or at least be transformed before calling. Yeah, so this oriented bounding box, this is basically if I could get that other code working, I could show you, but it's not working right now. I don't know. But basically, this OBB, this is just the bounding box around the object, right? So, like, I don't know how much you know about all this, but like if I just look at AABB bounding box, maybe there's a good, yeah. So you can see there's like it's just drawing the bounding box around these objects, and then in OBB is just takes into account rotation as well. So like this is an axis aligned bounding box, so it's always on like XYZ plane, like the basis vectors or whatever. But an oriented bounding box is actually rotated. So that's all this is. It's just the bounding box for every object. And then an object is, an object has, multiple instances per object. Yes. And so that's why I have this instance count here. So what I'm doing is I'm going over all of the instances for this object, and I'm setting them to be whatever the visibility of the overall object is. So it's kind of a bad solution, right? Like a to-do improve this only works for low instance count models. But it should be an improvement over what I've had before. Yeah. So it's kind of a bad solution. And then this here to try to like translate between the or map between the object ID and the list of instances for that object. This is what I've been having. This is what like most of the trouble I've had is trying to figure out the right way to do this. And I've almost got it working. Yeah, like I just got the hard part working. You just have one big instance array, which then has a reference to the underlying mesh. Well, yeah, I would think you'd always want it to be the other way around, right? Like you'd want, so like, just if I'm thinking about how BK, or yeah, maybe if you're not doing like indirect index drawing, it's a little different. Oh, hold on, this is off screen. Right, but how this works, you kind of have to do it this way, because like you have this, basically how I'm picking the material, or I'm actually picking the material with the draw ID, but the old way I was doing it, I was using this like first instance, Oh yeah, mesh shaders. Yeah, okay. Yeah, I haven't got around to doing mesh shaders yet. I do eventually want to try it out. I just haven't got to it. Been doing other things. Yeah, so like this is like the old way how I got the materials. Now I'm using the draw ID. It's similar. Yeah. So anyway, there's definitely a problem here for this instance's offset, which this is supposed to be like the offset into this object instance ID's buffer. These seem to have duplicates in them, but it was weird because even when I disabled all the extra threads, it still has duplicates. So I think there's something like very wrong with my with the allocator I'm using for it. Or where is it? I can never remember. Yeah, okay, here it is. Yeah, I think it's this linear allocator I'm using. So yeah, so instance calling data allocation. And what am I writing to it? So I'm writing instance IDs allocation offset. And all this is like, it's so much to try to keep in my head all at once too. So that definitely slows things down. Yeah, so then I have the allocator, and so when I create the object, I want to allocate I want to allocate a block of instance IDs to put in so I'm allocating in this buffer here, this object instance IDs, saying, hey, give me just some block of data in there that has the count of these instance the byte size of these instance offsets times the size of uint32t. And then I'm getting the offset of that big allocation block. And then in that allocation block, I'm writing the instance offsets. And these are global now because I'm adding the first instance to it. So these are global instance IDs that I'm writing to this global buffer. And the offsets all, or where is it? These all look correct for the most part. But somehow this allocation, I'm having like multiple of these allocations that have the same offset. So I'm like writing, like I'm writing these to the same spot. Yeah, so like since its offset is 0 and 0. Just not right. Well, actually, I want to make sure. Let's see, is it a problem with how I'm uploading it to the GPU, or is it that the allocation actually has duplicates? So every time I allocate one of these, I'm going to say got instance IDs allocation with offsets. Object instance IDs allocation offset. So close render doc. So 0. Okay. But if I look here, these offsets actually look reasonable. 0, 4, 8, 12, 16, 20, 24, 28, 32, 36, 40, and then 500. So that's, I mean, it jumps to like 500, but that's probably still fine. It's just however the allocator is working. Because I'm like, yeah. I mean, my allocator library isn't perfect, so it's probably just like wasting space. Oh no, there shouldn't really be any fragmentation because I haven't deleted anything yet. I'm not sure why this jumps to like 500. Or, yeah, because there's not 500 or how many? No, No, I'm only doing 10 of these. And I don't think any of the meshes I have 500. I think one of them has like 70 or 80, but not 500. Oh, right. But then these are in byte size, right? So this is like 10 and this is like 125. Yeah. So it actually makes sense, right? So like this is probably like the engine, and then this is like the chessboard, or like the other way around. I don't know, one of the two. So those actually make sense, and these offsets actually look reasonable. But then when I write those to the wait, what? This is running, but I can't open it. What's going on? Yeah, so many fix me's, yeah. No process found. It you can't see, but it says it's still open for me. What's going on? Yeah, okay. Yeah. So instances drawn 0, 115, yeah. Whatever. So 0, 4, 8. Yeah, so those all look good, but then when I look at that in RenderDoc, it's very wrong. Oh, what have I done? Why I don't care about icons. Whatever. So pull this up in RenderDoc. And yeah, and now these have like duplicates. 0, 0. Okay, so first thing, I want to divide all this by 4. That'll make it just easier to read overall. Is that KDE? Yeah. Yeah, I'm using KDE on NixOS right now. I used to use like tiling window manager stuff. I got tired of configuring it, really. Because I do want to go back to using tiling window manager. I just don't want to configure it and have to deal with all that. So I don't know. So let me see. Let me actually, yeah, when I write it. So yeah, way too many pop-ups in KDE. Let me see what I'm actually writing here. Writing instance offset. Data dot instances offset. Maybe I'm never running this. That's probably, I'm just never running just never running it. Use i3 on Linux, haven't touched config. Yeah, I used to use xmonad for a long time, like years. And then, yeah, I stopped using it for some reason. I don't know. I think I just got tired of dealing with like little issues, and then I want to switch to i3 at some point. I just haven't got around to it. Yeah, I'm probably just never calling this, and that's the whole problem here. Yeah, I would assume that's the issue. So let me close this. Oh no, but then I wouldn't. I don't know. No, it's still broken. Yeah, and so yeah, but now I can't really tell what's a duplicate and what's not. Kind of annoying. Yeah, I'm writing stuff to 0. Refresh calling data. Or no. Yeah, that actually should run because yeah, when I'm creating the object, I'm registering it as an invalid object, and then when it gets registered as an invalid object, then what happens is when here, object manager refresh invalid objects, then it'll go and call all the to update all the GPU data stuff, right? So like that's for I can call this to like set the position, and I can call it just at any time that I want here. And like this doesn't immediately update it on the GPU. It only updates it on the GPU once I actually call this object manager refresh invalid objects. And this also lets me do this multi-threaded, right? So like I have this in here, object refresh threads. I think this is like 15 by default because I have like 20 threads because I have an Intel CPU with all efficiency cores or whatever. But yeah, so then I can like update all the objects across like 15 threads. So that's how that works. Yeah, and so this should just run once per object because I'm not moving anything else. So that's actually correct then. Yeah, because not moving anything other than the camera. Oh, and the animation, but I'm not including animations in this yet. And this should be fine anyway. Okay. Let's just see what this says. Okay, so now we do have duplicates. So that's weird. Okay, and now the window is like hidden or something. Why? I don't know why, but now I can't. I'm like clicking the taskbar button for the window and the window's not showing up. I don't know what the deal is with that. Oh, I think it's just like KDE froze the task icon or something. I don't know. Anyway, why are these both? Oh, there it goes. I don't know. Yeah, and then I like 2 in here twice. Yes, so this should write to the allocation. Write instances offset. Yeah. This should not be in here twice. Object instance IDs allocation. Hold on. How does this work again? Divided by size. This is a fixed allocator, right? So the size is like the block size. What's the type here? No, that's actually not right. Yeah, yeah, I think size is wrong here. I think this needs to be or size of U at 32T. Yeah, I think so. Isn't size referring to size of the allocation? Yes. And so what I thought, I was a little confused when I was writing this. I thought these were, I don't know why I thought it, but I thought these were allocations with fixed size. So like in other places, I am doing like divide by size because, all right, I'm not doing it here, but I know in other places when I have like fixed allocation blocks, I'm dividing by the size of the allocation block. Instead of doing like size of uint 32T, and that just helps. That just makes it a little nicer if I like change something. But yeah, then I also run into issues. So I don't know. It's just kind of a bad interface. Yes, let's see what that does. Yeah, and eventually, so like kind of off stream, I've been trying to design like an ECS system. Okay, this looks way better. Yeah. Yeah, that's way better. I've been trying to design like an ECS entity component system off stream. Hey, everything's good. And then I'll probably like redo all the memory allocation stuff again after that with ECS built in, but I'm still trying to figure out like the best way to do it for my engine. Yeah, but this looks good. Why is this so small? Or is it just supposed to be that small? I don't remember. Yeah, but everything looks right here. Right, and then I can look away, and then I have instances drawn 0, and I go up to like 5,000 FPS. Yeah, that's great. So that was the problem. Yeah, and then I still have this issue. Like if I ever, once I start deleting instances and like adding stuff back, then this is going to get all screwed up. So it's a problem, but yeah, the culling is like decent. There's still some clipping problem. Yeah, now I got to fix the performance issue. So I'm going to turn off all the threads. And then I'm going to go up to, I don't know, let's just say 100,000 and see how long this takes. So yeah, recompile, so I get rid of that because I know that works now. So let's see how long this takes. Because it should take like 5 seconds, I think, but oh, well, 6 seconds. Well, no, because it's taking like 5 seconds to do like a million. Oh yeah, commit it. Yeah. Yeah, right. So I've got, what, 3,000 FPS looking here, drawing, or yeah, 2,000 FPS drawing 28,000 instances, and then I got 5,000 drawing 0 instances. Yeah, so it's pretty good. Actually, yeah, the culling looks, it actually looks fine now. Maybe that was a problem with the old engine as well. I was doing something weird, but yeah, the culling actually looks really good now. I don't see like, yeah, okay, there's a problem here with like that. I was pointing at my monitor with this purple box disappearing, but that's because I'm not taking animations into account. I have a fix me for that. So all I need to do is when the animation happens, I need to recreate the bounding box. That's all. And that'll fix that. But yeah, I want to fix the performance issue because that's a bigger problem. So I think I've been using hotspot. Yeah. So record data. That's all fine. All right, start recording. Failed to record. Permission error mapping pages. I thought I fixed this. Oh no, I just I have to like cat sysctl something. Or wait. Perf block. Permission error mapping pages. I forgot what this is. Or no, it's permission error mapping pages. Yeah. There's something. There's like some sysctl thing that I have to. It's like sudo cat. Yeah, perf event paranoid. Oh, no, maybe I. Let me see this. How does this work again? No, I don't want the file. I mean, I could just run hotspot as root, but yeah, just give me the documentation. Okay, yeah, disallow profiling. Okay, allow almost all events. Ignore mlock limit. Disallow ftrace. All right, I'm just gonna set it to 0 and see what happens. Oh yeah, commit. And close that. Object, and this is fix object calling data offset. Okay. Now just do this, and then echo 0 to proc. Is it already in here? So I thought I was doing this. Okay, yeah, echo -1. Yeah, there we go. Okay, hotspot should work now. Record data. Start recording. There we go. Yeah, so this will be kind of slow. It's just fine. No, I think perf should actually be like close to native performance. Yeah, it's not like Valorant. Yeah. So let me make this bigger. Now I can see what's actually going on here. Yeah, I think now I do file open or okay, yeah, just view results. Here we go. Flame graph. So yeah, queue submit. Where's create n objects. What is taking so long? Okay, so all this time is spent reallocating on the GPU. Like that's literally it. Or yeah, and that's because of this linear allocator allocate. So I think I'm just not pre-allocating stuff correctly. So if you look yeah, if you look here, like I have this create n objects, and this will like create a whole bunch of objects on a bunch of threads all at once. And then I'm running pre-allocate so that like instead of, yeah, I have like this pre-allocate stuff set up. So I'm just mallocing like all the size I'm going to need all at once instead of mallocing it one by one. But for some reason this isn't working, and I'm doing like malloc one by one, and that's why it's taking so long. I don't know what I did. Okay, whatever. I close that there? So yeah, so all this time is taken in a linear allocate alloc. Can I see? No. Okay. So I guess like one of these I just forgot to pre-allocate on. Are you calling pre-alloc in a loop somewhere? No. So like this just runs. So the pre-alloc. So let me go back a bit. So up here I have this object manager create and objects. And where that's the extra object count that's coming from here. So that's like 100,000. And that's just this is making me that like random 100,000 boxes. And so what happens there is an object manager. When I go and I create all those objects, what I'm first doing is pre-allocating all the space so that I don't have to call malloc a million times and reallocate and have to wait all the like so much time. But there's something that I'm forgetting to pre-allocate. So just like one of the buffers I made, I forgot to pre-allocate it, I think. So here, like I'm pre-allocating like some of the model data stuff. And then here I added this one for doing instance IDs. And so maybe, yeah, like I could put, yeah, probably the easiest way to do this is if I go into base allocator, where's one for GPU realloc? Yeah. And here I can just say reallocating GPU buffer name. Yep. And that'll just tell me what does model pre-allocate do. That pre-allocates the like the draw call and stuff and all of the, I think some of the no. It pre-allocates the instance data because, right? Let me see what it does. Yeah, it pre-allocates all of the instance data for all the primitives. Yeah, draw pre-allocate. So it basically ends up calling this draw pre-allocate for every single yeah, confusing name. Yeah, a lot of it's kind of confusing. Like it's something I just kind of like threw in there after the fact because I was like, wow, this is really slow to load because of all the malloc time. But yeah, basically it'll go over every draw call in the model and it will pre-allocate enough space for instances that I tell it, right? So I don't know, do you call pre-allocate in a loop? No, not really. Like it's not a loop, it just does like one big block all at once. Does that make sense? Now, like some of these, they do loop. So if I go down here into here, like grow or something, right? So this is for this contiguous fixed allocator, basically just like a vector. So what I do is I go to the parent allocation. I just call realloc once. So I say, hey, give me, however, I don't know, enough space for 1 million instance data blocks or something. And then I go and I actually like add all that to the free blocks. But like this doesn't do any memory allocation other than like new, right? And so like this could be sped up a little bit with like arena allocators, but this is where the bulk of the slowdown is, because when it reallocates the buffer, it's like a vector. It has to copy everything. So I'm doing that like 100,000 times or a million times, and it's really slow. But instead, I can just pre-allocate all the space I need, and then I just have to call realloc once. So it's like 1 million times speed up or something. Anyway, so this should print out the name of the buffer. Yeah, so it's object instance IDs. Okay. And is that not object instance IDs allocate or pre-allocate? So I thought I was, yeah, so I know something for this, but it's not, it doesn't seem to be working right. So pre-allocate, model, total instance count. Yeah. So I go to the linear allocator, and so I just wrote this pre-allocate, so maybe this doesn't work quite right. But what I did is I just like made a new block and reallocated parent and then freed it, right? So like it's the same thing I'm doing here for making a new block. Free blocks.push back. So maybe it's a problem down here. No free block found in linear allocator. No free block found in linear allocator. Okay. So it's getting here, and then it's reallocating this. Even though I should have created a block here. No free block found. Linear allocator. Let's see. Dumping free blocks. Yeah, or maybe if some of the pre-allocate stuff was confusing, maybe a better way to think about it is just like doing like vector reserve. That's all it is. I'm just doing like vector reserve, but for like the GPU stuff. So you create the block and free it on the next line. Free is this is not or at least I hope it's not doing. Wait. Yeah, I think I'm gonna make sure it's calling the right free and it's not doing like it's not doing like C free. So what I'm doing here is so maybe it's easier if I explain this. So I'm going over in this linear allocator, right? So this just has a whole bunch of blocks of whatever size you give it. And so I'm iterating over all the blocks. But I'm saying, hey, if you find a block that has enough size, then just decrement its size. And then return like this sub allocation that has that offset size. Otherwise, if you find a size that's equal, then yeah, just get the block and then like erase that block from the free blocks and then return it. And then if you can't find anything, then it goes down here and it allocates a new block, and its offset is starting at the size of the parent. So that'd be like the GPU buffer. So this will be like at the end of the GPU buffer is like the starting offset for this linear block, and then allocate and then have that be the byte size, and then whatever this is just parent or whatever. And then what I do is then I go to the parent, which would be like the GPU buffer, and I say, hey, GPU buffer, I need to reallocate or reserve, if you think about it like that, like vector reserve. But I need your new size to be your current size plus however much the size is for what I'm asking for to allocate. And then I just return that block. Instead, what I'm doing on here for pre-allocate is the same sort of thing, except I'm allocating this block, and then I'm just calling free on the block, which all it does is add it back to the free list. Like I could do the same thing with just like this is more clear. I would, I guess, if I did this instead. I mean, I guess it's a little more clear about what's going on here, but it does the same thing. Yeah, and then I reallocate the GPU buffer to actually have space for it. So yeah, but for some reason it can't find the free block after I called pre-allocate. And so if it can't do that, then I want to see what all these free blocks are, because I should have one that has like enough size, because I went and I did this, right? Model, total instance count. Oh, wait a second. Oh. Times count. I just forgot to do this. I forgot to, so I was doing model total instance count times the size of the instance data or whatever, how many instance IDs I have. But then I forgot to multiply by the count of objects. That was it. So this should go fast now once it builds. Yeah, so I don't think there's anything wrong with the linear allocator. I just forgot to multiply by count. Okay. Yeah, that was way faster. I don't know why. Yeah, so some of these, yeah, but some of these reallocs are probably fine. Yeah, like I could definitely speed things up if I remove how many reallocations I have. That's just vector reserved, so it has to copy everything, so it's O of n. But that should be fast now. Still slow to compile, but it's not as bad as before. I'm still printing that stuff. And somehow I have like unnamed GPU buffers. Not sure what's going on there. Anyway, how do I have one? Because I thought the constructor forces it to have a name. Yeah, what? How did I even do that? Is it something in here? No. Yeah, I have no idea how I did that. It has a blank name for some reason. I don't know. So run this. So there we go. Yeah. So it took 34 milliseconds to create the objects this time, which is way better than 6 seconds. And then the rest of this time, I think this was spent like loading images. That's all that is. And it's just like decoding PNG is slow. That's just how it is. Okay. So yeah, so that took 1.5 seconds. And then now I can go back to a million instances. And I think it's 15 of these threads and 4 of these threads. There we go. Yeah, so now I made 10 million instances, and that took like 2 seconds to load. So great. It's all working. So I don't know if you understood all of what I talked about with the pre-allocation stuff. So if you still have questions, you can ask me. But it's just vector reserve. Yeah, so instances drawn is what I'm looking at, 400,000 at 400 FPS. And then I look away, and now I've got like 2,000 FPS. Yeah, and so I want to do like timestamp queries to see the culling time, because the culling time does take a little bit, but still it's way better. Like it's culling 10 million objects at or 1 million objects at 3,000 FPS. So I think it's fine. Yeah, or what's the frame time? Yeah, the frame time is 0.3 milliseconds. So yeah. So that's great. Yeah, at some point I'll probably have to chunk the arrays. Yeah, like that's kind of what I'm doing now, if that's what you're asking. But if you're saying like chunk the arrays, but anyway, yeah, I want to. I don't know if I mentioned this earlier to you, but I'm working on redesigning the allocators again and replacing it with like an entity component system. But I'm still working out all the details on how I actually want to do that. But anyway, this is great. And like, it actually seems better. Yeah, there's still some weird, yeah, like that thing's disappearing when I look there. So there's still like some weird edge cases. I'd like to still be able to draw the bounding boxes if I can. Yeah, I need to fix animations. Because if they get too large, the reallocs will cause you to drop frames, right? Well, oh, yeah, I see what you're saying. Yeah, reallocate only part of the buffer instead of the whole thing. The problem with that is it gets kind of difficult to do that to really do that on the GPU. Like, because in the shaders, right, you just have like one contiguous buffer that you're reading from. And so like I could have multiple buffers, or I could have like a buffer of pointers to buffers and stuff like that. But all that indirection is just going to slow things down even more. And so, but like right now, so I only need to reallocate the buffer whenever I need more space. So as long as I'm doing reserve or pre-allocate or whatever, it's probably fine. Because like I can reserve 10 million instances in like a few milliseconds. And now I have enough space for 10 million instances, and so I never have to reallocate anything. So it's not like I'm going to be doing a whole bunch of reallocs every frame. I shouldn't be. If I am, then that means I need to add like some more reserving or pre-allocate stuff. But But like if I'm removing instances, I'm not reallocating anything. I'm just leaving the buffer size. Yeah. Now like maybe later on I could like free the buffers or something, or like shrink them to try to like reclaim GPU memory, but that's kind of way off once I have an actual working game and I'm worrying about like VRAM limitations. Yeah, but you have to bind the buffer every frame. I could swap it out without changing anything in the shader. Yeah, but then I have to submit like multiple draw calls. Since I'm doing everything with like big batched indirect draws. So like if I had like chunked buffers, right? If I had like buffers that handle, I don't know, 100,000 instances each or something. Well, then I have to run everything with the 100,000 and then run it again with like the new buffer and run it again, and run it again, and run it again. And that would leave the shaders the same, but now I have all this extra overhead. I just don't think it's worth it when I can just say, reserve me 10 million instances, and that's enough for anything that you're ever going to want to do. Like even 100, like it just takes a few milliseconds to allocate a huge buffer, if even a few milliseconds. Since it should be like constant time for the most part. It's just a problem if you have to call it a whole bunch of times. But I shouldn't be calling it a whole bunch as long as I reserve things correctly. So, so let me go ahead and commit this. Let me see. Yeah, that's good. That's fine. Yep. Reserve object instance IDs by count. Great. Yeah, now I would like to draw the bounding boxes, just because, I don't know, it's fun to see the bounding boxes at the very least, even if it's like basically working at this point. So where, no, that's not it. How are you going to bind different shaders if your whole pipeline is just one draw call? I don't see why those are mutually exclusive. Oh yeah. So I can submit multiple draw indirect stuff. Like if later on I want to do like deferred shading and stuff like that, and I want to have like a whole lighting pass, that's not really a problem, because at that point I will have to have like multiple draw calls, which is fine. So I can have like, but at this point I just have like one draw call per pass, or yes, sort of, or one indirect draw call per pass is a better way of saying it, because like the indirect draws are technically like multiple draw calls, but they're just a lot faster than calling draw a whole bunch of times. Yeah, so like there's nothing stopping me from having multiple draw calls for like deferred shading and things like that. So just like how I have, if I go look at the compute shader, no, like look at the compute shaders here. So I have like a dispatch per compute shader. So that's fine. And it would do the same thing if I have like multiple groups of like graphics pipelines of like vertex, fragment shader, and all that for like deferred shading. Yeah. Yeah, that's why I said think about rebinding buffers. Yeah, but yes. So I can. So the problem isn't in rebinding buffers. The problem is just trying to like isn't trying to manage that in the first place. So one, I just have to keep up with a buffer per 100,000 instances, and two, I do have to actually split like the vertex and the fragment shader into multiple draw calls, which just adds overhead and complexity that I don't think I need, because if I just say, hey, pre-allocate me 10 million instances, then that'll just like run once at the beginning of the game, and then it doesn't matter at that point, because I'm not like freeing the buffers at all. So It's just like extra complexity for no benefit. Like I could do it. I just don't see what the benefit would be. When I can just reserve a giant buffer at once. Right now, if I didn't have like reserve built in, then yeah, that would kind of make sense. But still, like, reserve is just how arrays work, or vectors, or whatever you want to call it. Hard to explain to a chat. Okay, yeah, maybe that's just part of it. Yeah. Anyway, I wanted to look here, and let me compare this again. Not rewrite, this one. Yes. So in here, I have some code for drawing. Oh, and here, actually, I had another graphics pass right here. Somewhere I have some code for drawing the bounding boxes. Somewhere. Here's some of it. Here's like generating the commands, so like vertices, indices, OBB command, shader, box, options, pushback, OBB, draw. And so what's... Okay, instance count is objects.size, index count is box line, size times 2. Yeah, okay, that makes sense. And rendering, draw indirect. Yes. Okay. Timestamp commands. Draw indirect. Okay. So why can't I just add this to this call? Why am I doing this in multiple calls? Oh, right, because I have to rebind the pipeline. Yeah. Okay, that makes sense. And then the shader, okay, yeah, and then so I have to support line lists. And where's the shader? Must have passed it. Oh, yeah, okay, this is it. Box.vert, box.frag. Okay. And then I think, yeah, if visibility buffer of object.firstInstanceID. Yeah, that's fine. Okay. Then I will take this, and this is my vertex shader. So assets, shaders, graphics, new file, box.vert. This in. So yeah, let me copy paste this. There's OBB and then object call data. That comes from here now. That needs to be whatever this is. Object calling data. Objects. Visibility buffer. Right, this is UN now. Yeah, I had some problem earlier. Like, I want this to be a buffer of bools, but there's something weird with the shader compiler in that it's like promoting this to a buffer of uints automatically. And then like I'm trying to check if, and so like if I'm trying to check if something's visible, I'm basically just checking if it's non-zero. But then that has a problem that it'll put like random garbage. Like there might just be random garbage at those values on the GPU, since I'm like just setting the least significant bit. And so like, it's terrible. So this has to be uint instead of bool. And eventually what I want to do is pack this, because like I should be able to store like I should be able to store 32 booleans in one integer. And right now I'm just doing like one boolean per one integer. Yeah, just set the bits within the uint manually. Yeah. So I'm doing that for just one bit right now, and then eventually I'm going to get around to packing it. I just haven't done it yet. But yeah, in here, yeah, I'm just like converting the boolean to a uint and setting it, whatever. Yeah, but I know I can pack these together. The problem is just like problem is like dealing with these indices and all that, and I just haven't done it yet because it's not important, because it's still like like it's like 32 megabytes for a million instances. And so, yeah, it could be 3.2 megabytes, or no, it could be like 1 megabyte for a million instances. So it's better, but it's 32 megabytes. Like my GPU is 24 gigs of VRAM, so it's not a priority basically. But I do have a fix me, so yeah. So this can be in position. This can be out color. Location 0 out, yeah, that's fine. Set 1, yeah, that's fine. Object data, this is now objects. Object OBB. OBB vertex. Position half extents. Bat3 rotation matrix, oh man. UVW rotation matrix, yep. Proj view is projection view. And then this isn't first instance ID, this is instances offset. And then, yeah, if it's visible, still be a lot faster since you're using less memory bandwidth. Yes, but it's 32 megabytes. Like, XTX memory bandwidth. Yeah, it's not just that, like, performance is a priority, but like, yeah, I got 960 gigabytes a second of bandwidth. And so like 32 megabytes is, it doesn't matter. But yeah, I mean, maybe I'll go from like 3000 FPS to 3300 FPS. I don't know. So whatever. But yeah, I do have a fix me in there. Eventually I want to do that. I just have to figure out how I want to deal with the indices. So like, I don't want to do it and get that extra 5% or whatever. But anyway, I got bigger priorities. Yeah, GL position. Yeah. So then this is, if it's visible, then set it to green. If it's invisible, set it to red. Okay, that makes sense. And then the fragment shader is just output color. Great. New file box.frag. Okay. In flat, in color. Yeah. Out color. So yeah, so that's the shaders, and then I just have to actually run the shaders. And those use the same buffers, right? Yeah, those don't use any new buffers. Great. So I'm going to go into the renderer. So begin rendering, graphics pass, run that. Right, and then now I want to add a graphics pass for the box. So how did this work? Update OBB, that's not it. Coin data. Yeah, that doesn't matter. Some call push constant. Yeah, memory barriers. Okay, here we go. So yeah, after the draw indirect, so do I need a barrier here? No, I don't. Sweet. Yeah, here we go. So I want a graphics pass, and this is going to be just do this. Except get rid of this, or just this one. Base shader name equals box, or yeah, vert shader path, frac shader path. Those are the same. And then this is, yeah, that's fine. Okay, and then, but these draw allocators, okay, so this is the vertices and indices. So I need to upload these into the vertex and index buffers. Or, Yeah, so that's fine, right? Because I can put these in the same buffer. Yeah. Move some of this. Yeah, so these are like the vertices and indices for just drawing a box. And then this is the draw commands. The draw command. Okay, and then objects.size, instance count. So this is an issue, right? If I like dynamically add and remove objects, this instance count needs to change because this is one per object. So this might be not trivial. Yeah. Thought this was just going to be like easy copy and paste. I might be able to hack something together. So OBB commands push back. Buffer box draw command, draw indirect. Okay, yeah, so I want to run draw indirect. What does it look like up here? Yeah, right, so I don't need a count buffer. I just need a really simple one. Still can do this. And I can do something really stupid here. Yeah, I'll probably do that. So yeah, so how the render graph works right now, I don't know if I've explained this to you before, but it's I tried to get rid of some of the boilerplate because in the old engine I like wrapped every Vulkan function that I needed with like my own C++ function for integrating the render graph. And this time I try to make it more generic by saying, hey, what if I just gave it like a lambda function that has the or like I could like do a lambda function, or I could have like function pointers to Vulkan functions and just like pass the arguments with templates. But yeah, with doing like variable arguments and stuff. But this ended up just being like a mess. And so I am actually going to go back to the old solution of just have a big file somewhere that integrates all like the Vulkan commands I need into the render graph. Yeah, because like this like node op equals this crap. Like this is already kind of confusing. Like add dynamic node, and then if I go into here and I'm trying to deal with like the color attachments and stuff, like this is just terrible because I have to make like shared pointers for all these structs, and then like pass them in here to hold their lifetimes, and then pass them into the lambda, and then set this to like have it update every time, and then I can begin rendering with this, and it's terrible. Instead of just like having one function that I call and it does it all for me. But anyway, this is how it works right now. So, end rendering. Yeah, so draw indirect, right? So this is just draw indexed indirect, and then pass in the command buffer, and then, yeah, so it's not, so let me just look up the function prototype BK. CMDBK, COD draw indexed indirect. Oh. The nested lambda is just question mark. Yeah, like it's really confusing how all this works. Like that's why I just copy and pasted it from here instead of trying to remember how it works. But it's something like so like this is a dynamic node, which means that the actual operation that it does can change. And the reason it's a dynamic node is because the underlying like Vulkan buffer for the draw commands can change in case it gets reallocated. So then this means that every time the frame runs and it gets to trying to record this draw command, then what it'll do is first it'll run this outer lambda function to set the node operation. And that node operation is a lambda function that takes a command buffer and records a Vulkan command to the command buffer. And then it'll actually run this operation. It's terrible. But it does work. So, yeah, but I'm going to redo this. I'd like to get rid of the boilerplate, but I guess it's just kind of like a trade-off between how, like, I can have it give like zero context at all with these like dynamic nodes, but now I have to like specify a whole lot of context within here, like every time I use it, or I can just have a big list of functions that puts the stuff into the render graph, and that'll make it a lot easier. Because like if you look at the old code, yeah, like the old code here, like it's just shader and it's just draw indirect instead of this garbage. Anyway, you look up this. Why wouldn't you add why wouldn't your add dynamic node just take the inner lambda and assign it to the node itself? Why wouldn't your add dynamic node just take the inner lambda? Oh, because this code here, this has to run every frame. That's why. So yeah, like this is how it takes the inner lambda, right? So if I move this over, I can go a little more into detail with this. So this render node, it has an operation, which is just a function that returns void and takes in a command buffer. And so this is like your actual Vulkan command just wrapped in a lambda function. And then it also has this update function here. And this, but why it's just assigning a lambda to the same node over and over. The reason is because I need this stuff here to run. This GPU allocator get buffer cold draw commands buffer. Because this buffer could get reallocated, which would mean the underlying Vulkan buffer would change. And so I have to run this every time to refresh the to basically refresh this command and its arguments. So it actually records the right stuff. But doesn't that run when you assign the lambda? No. It only runs where is it? Under graph. So if I go up here, where is it? Yeah, so record buffer. So here, what I first do is I run the render node update function. And then I run the operation. And so what that update function is this outer thing here, right? And on this outer thing here is I'm setting this node operation to be a new lambda function that takes I'm setting the operation to be a new lambda function that will get this buffer, and then I'm actually running it, and so it's a mess. And yeah, now I'm thinking about it, this might not need to be a dynamic node. This might just need to be a regular node, or yeah, I think I could probably do like a regular node here actually instead of a dynamic one. And just, yeah, have the operation be, I don't know why. I don't know. This works. It's horrible. Yeah, but I think I probably could just set this to be the node, to be just be a node, right? Because then like when it runs node.op with the command buffer, whatever, it should still recall this stuff anyway. So I don't know why I did it like this. Yeah, like if I was passing directly in the Vulkan buffer, then yeah, I'd have to do it. But I don't know. Anyway, this is what I actually want to work on is down here. Yeah, exactly. Yeah. So it's... Yeah, I'm confused too. Yeah, but it does work. I know that. Yeah, I could probably set it. Yeah, I guess it just depends on like weird things about how C++ handles like when it actually like runs these parameters, but I'm pretty sure it only runs this when I actually call this here. Anyway, I've got the command buffer, and then this needs to be not called draw commands, but it should be like OBP command. I guess. And then 0 for the offset. The draw count is the size of that. And then the stride is, okay. So the stride is size of dk draw indexed indirect command. And then the draw count is, I guess it's just 1, right? Because I only have one draw command. And this probably doesn't need to be a dynamic node. This can probably just be a regular node because this buffer isn't going to change. Now to look up how to actually do a regular node. So this takes dependencies and an update function, you void update, then a function, and then arguments. So do you have any dependencies? No. Do you have an update function? No. So this is a void update. And then it takes the actual Vulkan function itself, and then it takes the arguments to that Vulkan function, which is this stuff. And then I get rid of all this. Okay. Yeah, so this is like how it looks with just a regular node without all the dynamic crap in it. So it's a good bit simpler. So this is add node. So this here, this you can just define a vector of shared pointers, and that'll just let the node hold the lifetime of any like structs or things you need. So like I showed that earlier in here. So like I have these shared pointers, and then this node like owns it. And then I don't need to run anything before. I don't need to run anything before the before draw indexed indirect. So it's a void update. But sometimes I do need to do stuff. So like here, when I'm about to do begin rendering, I need to get the current image view of the swap chain. So this will run first, and I'll set like these struct parameters, and then I'll actually run the Vulkan command, right? And then I have just the parameters of the Vulkan command, and this is just like variable argument templating stuff, like this. And yeah, I'm not quite sure why I did dynamic node, because like I can just put stuff in the update function anyway. Or oh right, it's when I want to. Yeah, I had to do all this weird nonsense because this is when I want the update function to actually edit the node itself. And so I have to be able to give that update function a reference to the node. And so I can't just use like add node, right? Because this update function, this is like void, it takes no parameters. But here the parameter for the update function is actually a function that takes a node. I probably didn't need to be doing that anyway because I think no, I can't do that because this is gonna run at the time I actually run add node. So this has to be a dynamic node because I need get buffer to run every frame. So that's why it's there. Basically because I need to be able to get a reference to the node itself instead of just like editing some of the dependencies. But in this case, the OBB commands, the buffer is never going to change. So I don't need to worry about that. 0, 1, yeah, right, because I just have this one command. The only thing that's going to change is this object count. So I actually do probably want an update function that will change the object count of this. And so actually, okay, so this doesn't need to own the lifetime. Yeah, I think what I need to do, so this needs to be a lambda function, takes nothing, but it will, I think I can ask for references. So I'm going to take the GPU allocator, And I want to get the buffer of OBB commands. And I want to get its mapping. And then I want to reinterpret that. Reinterpret cast as a pk draw indexed indirect command pointer. Cast away qualifiers. Right, that returns a const reference. I guess I can make it non-const, whatever. It's fine, I guess. Even is a stupid thing. Yeah, is this the right way to do it? Well, No, yeah, this is the wrong way to do it. Yeah. That's kind of a messy way of doing it. Instead, I need to be using like a sub-allocator. So when I get down here, first I want to actually create this buffer. So let me create the buffer. Arguments. Okay, so this is like vk buffer usage. Indirect buffer bit, and then vk memory property device local property host visible, and this is called OBB commands. Memory property host visible. Why is this mad at me? Did I forget something? Storage, oh, okay, I need that storage buffer, but like this should work. Okay, buffer usage, storage buffer bit. I don't even know if I need to add storage buffer, but VK memory property, oh, host visible bit, that's why. I don't know if this actually has to be a storage buffer. Anyway, so there's OBB commands, and then right, but then I want to create an allocator on top of this. So auto, I want a new, contiguous fixed allocator. Or auto, whatever, TMP, I'll name it in a second. Contiguous fixed allocator. Well, yeah, actually, this should just be exactly the same as how indirect commands works. Yeah. It's like just this. Except instead of draw allocators indirect commands, this should just be OBB commands. And it should be OBB commands equals new contiguous fixed allocator. Yep. And then the renderer, I can just put this in here. So I can say, what is this? This is a contiguous fixed allocator on top of a GPU allocation pointer, OBB commands. Here we go. And then OBB commands, alloc, yeah, allocate me one command. Yeah, so, I mean, really this should be GPU allocator, just future-proofing here. Get buffer, OBB commands, size divided by size of VK, oh, next indirect command. Yeah. So that way I don't have to worry about changing it in case I add one in the future. But yeah, so I allocate one of these, and then this is a sub-allocation on top of a contiguous fixed allocator on top of a GPU allocation, and it's a pointer. I'm going to call this box command 0 something. Then I can say box command 0 write OBB command. There we go. This is the correct way to do it instead of trying to like directly get the pointer. Okay. And now I can actually go later on and update this easily. Yeah. So yeah, what I actually want to do is box command 0. So let's just say OBB command, and then this should be whatever. It should go in here. OBB command. OBB command. There we go. And then I can go up here, or yeah, okay, I guess I can do this first, right? I can say instance count is 0, and then OBB command write OBB command, and then yeah, so ideally I'd put this in the update function in here about updating the instance count. So what's a good way to get the instance count? Well, that should just be, right, so this is 1 per object, so I want to get the object count. So do I have the object count in here somewhere? Yeah, RG render. Well, one of the buffers should be the size of the object count, so I guess that could work. Yeah. So I want 1 per object. It's not the size of the visibility buffer. Yeah, it's the size of object calling data. Yeah, because I want one of So that's really what I need to be doing anyway, since it's tied to this object calling data. I need to be setting the size of it to be the number of entries in here. So I can get this buffer and divide it by that size, and then that'll be the number of objects I have. So in here, then I can take OBB command write, or no, hold on a second. Yeah, I have to read it first. Underscore OBB command or get. Okay, yeah. So I have to do it like this. And then I say OBB command get, since this is getting it from the GPU. So I can get, I can get whatever data is in here, and then I can modify it. So I can say the instance count equals GPU allocator, get buffer name is object calling data, get buffer object calling data, size divided by size of object call data, and then I can write this back to, does write take, yeah, it takes a void pointer. Okay, so that should work. Yeah, so I write this the first time here, just to like set everything to 0 and set the index count. And then here, since, I don't have something set up to just like write to a specific offset, so maybe I should add that. So because really this is for like writing blocks of data at a time. But I can get what's in here first from the GPU, and then I can change the instance count, and then I can write it back to the GPU. So to remove the get call. Okay, so that should work there, and I think that's everything. Do I need? No, I don't need like any barriers or anything. Okay, let's see what this does. I did. Oh wait, I didn't upload the vertices. Hold on a second. Okay, yeah. First index, vertex offset. Yeah, I need to set this stuff. First instance is 0. Yeah, that doesn't matter because, yeah, I'm not using that for anything. Or no, I am using GL instance index. Yeah, but that's fine. That's fine. Instance count, I'm setting there, but I still need first index and vertex offset, so I need to upload these. So, all right, so there's the command. So let me just upload these up here. All right, so does the vertex buffer even exist yet at this point? No, or maybe not. Well, no, I want to get vertex buffer. Yeah. How am I doing this? In draw. Yeah, so this stuff here, basically, is what I want. So vertex alloc. So this is draw allocators. There we go. Vertex allocate box vertices dot size times size of box vertices of 0. Auto whatever. Fix that in a second. Here's vertex offset. There we go. Then I have to actually upload the data. So box vertices data. And then index count is, yeah, I already have index count. And then first index is index alloc, draw allocators, indirect command, index count. What? No, okay, no, that's not right. Yeah, this is how many indices I have, which would be this. Hold on. Because this is a vector of vec2s of ints. It's, yeah, okay, so it's this times 4 or something because they're ints. Yeah. Allocate. Yeah, box lines 2, yeah, because I have box lines dot size times 2 times size of, I don't know, UN32T, whatever. And then first index equals this, or that, times size of divided by, or first index, or yeah, okay, divided by size of UN32T. That's better. Or, okay, and I still need to write, wait, what? First index, wait, what? No, I think that's, no, that's not right. That's because I removed a semicolon. Okay, almost there. So this is box lines.data. Yes, and then vertex alloc, index alloc. Okay, and then whatever. I don't have to clean these up right now. I just want to see this working. So hopefully I don't crash. Okay. Boolean expression expected, compilation terminated, box. Line 44, yeah, it's because I turned this into a uint, so I need to, yeah, if visibility buffer of this equals 1. So if it's on, then green, otherwise red. Vertex input, okay, hey, oh, I forgot to set it to, I forgot to set it to line list, so it's trying, it's interpreting those as triangles. Well, we didn't crash, so nice. But yeah, I don't know. It's Christmas, yeah, and so you can actually see the, you can see kind of. Oh, this probably looks awful with the compression, by the way. But yeah, so so yeah, looks funky. Yeah. So the problem was, I so the boxes are made of line primitives, but I'm telling the GPU to treat them like triangles, and so you get this mess. So anyway, yeah. So like if you look here, you can kind of see how like the triangles are supposed to be enclosing this. Anyway, and it was giving me some validation errors. What was this? Vertex attribute at location 1 not consumed by vertex shader, by 1 and 2 not consumed. What? Shader module. This should tell me the name. Vertex input state. Okay. Well, maybe it was something. I'll set it to line list and maybe it'll be a little better. Yeah, vec3 in position. Shouldn't this be like vec2? Might be something wrong with this. Or yeah, I think this should be vec2. Anyway, let's set it to line list first, and then I can figure other things out. So, what I need is, let's go to the pipeline. Somewhere in here, I'm setting it to like triangle mode. Yeah, okay, there we go. Topology is triangle list. Why do I have 2 constructors again? I don't remember. What's the difference between these? I know there's like some important reason why I have 2. Oh yeah, if I don't have. Oh yes, like if I'm using descriptor buffers or not. This is terrible. Whatever. Can I read the topology? Maybe I can read the topology from the shader, right? Because like if the vertex shader is vec2, then that should be line list. And if it's vec3, then it should be triangles. I think GLSL line topology. Like I'm pretty sure it's supposed to be vec2, and I just have it as vec3 for some reason. GL lines, vertices 0 and 1 are aligned, 2 and 3, triangle strip, quads, patches. Right. So yeah, let me think about what this is doing. Yeah, so I have vec3 in position. Okay, but then this has XYZ. How does this work? I'm confused. In position XYZ. All right, okay, so I get that I need like XYZ coordinates. Oh, yeah. So the vertices, yeah, so the vertices are 3 points. Yeah, right. Because if you think it's like a box I'm drawing, right? And so you have like the XYZ of each point on the box. But the indices are only 2. So that's why. Okay. So it actually is supposed to be vec3. So then can I see like, yes, so the indices are grouped up. So the indices are double. Yeah. But this is just to make it easy for me, right? Like this doesn't actually mean anything. This is just a buffer of indices. Yeah. Okay. So I'll just add something to the constructor to set the topology. Whatever. I just hate making these any bigger than they are. So whatever. BK primitive topology. BK primitive topology. Topology. This goes here, and I have an extra comma. That's a topology. And then grab this again, or yeah, whatever. Go to pipeline. So that's topology. That's sort of topology. Comma here. And then from like here to here, I think. Down here. Yeah, there we go. So there's all that. And then, okay, so then graphics pipeline, that gets called in the render graph. So graphics pass. Yeah, so I also have to pass it in here, right? So topology. Oh, that I accidentally quit Emacs. Source renderer here. Or where was I? Render graph. Topology. Yeah. I have that here still. Yep. Graphics pass. Fine. I will default this to be VK. What was it? VK primitive topology triangle list. There we go. Now pipeline renderer graph. Renderer. Yep. If I go down here, where's my graphics pass? Here we go. So draw calculators, vertex index, no specialization data for either one of those, and then this is primitive topology line list. I might reorder these so I don't have to set null pointer here. This is for vertex specialization, or for shader specialization constants. So it's just like doing like hashtag define or whatever in C. Same kind of thing. Anyway, yeah, so that's a line list now. So let's see what this does. And I don't know what's going on here because this shows up in the other one as well. Handle, and I should be setting debug info for the shader module. So maybe that's, so I can at least see which shader it's doing it, but I would assume this is like vertex and fragment. So when I create the shader module, maybe, yeah, okay, yes, let's create graphics pipelines, right? So it is when I create the shader module. Yeah, I just want to set the debug name here. Device, set debug name, no. Is this, how does this work again? Set debug name. Set debug utils object name. Vulkan debug object name. Or yeah, VK object type. That's really what I want to look at. That's not it. What's VK object type? Should be shader module. Yeah, what? Just didn't want to show up. VK. Here we go. VK object type shader module. There we go. And then what were the other pieces for this? What were the other? I know I need the name, and then, oh yeah, I need like the name and then the pointer. So I don't know. Module, and then the name is the shader name. So this would be just path. Did I put these wrong? The wrong order. Handle name. Oh yeah, this has to be, I think it's just this. UNT64T. Set debug name. Oh, right. Device set debug name. There we go. That should work. That's just for, with the validation layers, you can convert these handles into like a reasonable name so you know what is actually having the problem. And that's all that was. So now, yeah, so now you see here. Okay, so this is interesting. Things are still kind of wrong, but it's a step in the right direction. Why are these still triangles? Yeah, so maybe it's got something to do with this box for shader module. Vertex attribute at location 1. Oh, yeah, that's because I'm not reading. Yeah, I know what that is. It's fine. It doesn't matter. I'll show that in a second. But let me see what's going on here. So, yeah, I think red means cold, or no? What do these mean? Because this is still very broken. Assets build. What? I don't know. Yeah, so if it's visible, then it's green. If it's supposed to be invisible, then it's red. So I don't know why these are invisible, or why these are visible when they're supposed to be red. Or, yeah, something's very wrong. And then also, like, these aren't... What's going on? Like, they're not actually covering the thing. And I know this... I thought this worked in the old one, at least. And, like... I mean, when it all turns green, my FPS drops, so maybe it's kind of working. I don't know. Something's definitely wrong, because it's not even drawing these boxes correctly. Maybe it's some weird thing about, like, memory layouts. It's still neat that, like, I got all this working. It's just, I would like to actually draw the bounding boxes, the correct ones, instead of whatever's going on here. So, yeah, I'm drawing, like, half of a bounding box. I don't know. And I thought these vertices were, like, exactly what I wanted before. And then, like, there's just some random garbage right here. So I don't know what that's about. Yeah, definitely some problems. And this is probably destroying the compression right now. Yeah, still pretty cool. So, what would even be causing this? So, like, some of this could be wrong, but it seems relatively simple. Yeah, and then I just rotate it. There's rotation matrix. Like, there's not really anything too complicated here. I don't think it's got anything to do with this. This is just like performance warning, something. This is because if I go into the shader or the pipeline, I don't remember. I think it's the pipeline. Yeah. So there's this fix me, get this from Vertex shader. There's this binding description and attribute descriptions. What that's for, is that a model? Where? Oh, so it still says new vertex, so I need to change the name of that. So let's just do that right now. Go to type definition. Yeah, here we go. So let me change the name of this to just be vertex. So what this is just like some Vulkan stuff that actually describes the inputs and output, or yeah, the inputs of the vertex shader. So like this is what the vertices are actually supposed to look like. And so maybe this is causing a problem. I don't think so though, because like it's set to line list. This is a little different than that, I think. Vertex. Maybe this is causing the problem. Yeah, and so I want to be able to get this from the shader. And I can probably do that. And that might fix this. Save that here. Yeah, binding description. I'm not sure. Because it might be like reading. Oh, no. I don't think it would be reading over the data in like in here, because like I'm telling it, oh, just read vertex 0 and vertex 1. And I just have this data in here. And so like it knows that maybe not. Maybe it thinks the vertices are supposed to be bigger. Could be possible. And then it's like reading over extra data, and that's why I have missing vertices. That could be it. And then still like the visibility buffer isn't working quite right. Because like I'm seeing this, but it should be green, not red. Yeah, and then like this disappears, so I don't even see anything change. So I think first I'd like to get the bounding boxes drawing properly, and then I can worry about like if the yeah, I can worry about actually fixing like the colors and all that. Yeah, and so the first thing to do, I guess, would be test and see if this is the problem. So also, I've been on for like 4.5 hours. I'll probably try to fix this, and then I'll get off for the night. Yeah, but anyway, so let me figure out this stuff. Was this in draw? Yeah, this is in draw. So basically, I just want to get rid of this. Yeah. So the attribute description, binding 0 location. Yeah, all this I should be able to just get from shader reflection. Like that seems. Yeah, I should probably sleep too. Yeah, like I'll be done in like 30 minutes, and then I'll be back tomorrow. And then binding description is okay. This is pretty easy here. Like I think this is always the same, pretty much. Well, yeah, stride is different, but yeah. So like maybe it's the stride variable that's screwing up the lines. An attribute descriptions. Yeah, and so like the format. Yeah. So like if it's a vec3, I can just say, oh, all vec3s are this, all vec2s are this, all vec3s are this. So like in the triangle here, I have in position, text coordinate, normal, tangent. I don't think I'm using tangent. I don't know. Yeah, I don't even have tangent set up in here. And then in the box, I have in position and outcolor, right? So I just have in position. And these are what my vertices actually are. Yeah. And then the indices are just indices into my array of vertices. Okay. So let me look up Spear v Cross documentation, because that's what I'm using for reflection. So Spear v Cross reflection API user guide. So will you tell me the vertex? I think so. Yeah, stage inputs. Yeah. Vulkan concept. Input attribute description. Okay. So this is what I want here. Shader resources member. All right. Let me put this. Yeah, whatever. Yeah. So in the shader, so where I'm doing, yeah, so this is where I'm doing all the shader reflection to figure out like all the buffer names and specialization constants and push constants and all that. So now I want to get the input binding description, but I only want to do this if it's a vertex buffer. Otherwise, I don't really care. So yeah, I think I have like somewhere. Yeah, I'm keeping track of like the shader stage. That's here in compile. Do I have like shader stage in here? There's bind point. That might be what I'm looking for. Bind point is flag to bind point. What is this? Flag to bind point. Oh no, that's just graphics. Okay. Then what I'm gonna do is where is it? Yeah, get stage path. Yeah. And this returns ESH. Okay. So get stage path, and then auto tie something like this. Geo slang stage. Vulkan stage. Is this how this works? How does this work again? Where am I doing tie? Okay, so I have to define these ahead of time. Okay. Yeah, or I might just be able to like do it in line with a pair or something. Standard pair. Does that work? No, because these still need to exist. Okay. I'm going to do tie there. And then this is like ESH lang or something stupid. I don't really care about this. This is just for the GeoSlang compiler. GeoSlang stage. GeoSlang stage. There we go. Vulkan stage is what I actually care about. And so that's a PK shader stage flag bits. Stage flag bits. Vulkan stage. Yeah, I like how like in Go and stuff like that, you can just put an underscore and do ignore, but C++ doesn't really have that as far as I know. Anyway, you need that there. And then if Vulkan stage is equal to PK shader stage vertex bit. Actually, I think this should be, it's like and or something. It's not double, whatever. It's fine, because this just returns vertex bit anyway. Okay, yeah, so if this is a vertex shader, then I want to say for const spear v cross, what is this? Subpass input? No. Or I have no idea. You're just going to be auto for now. Auto const reference vertex input in comp.get what is this? Stage inputs? No. The documentation here, like the documentation for this is pretty bad. Because like, okay, it says shader resources member stage input. So this is, okay, so this is res dot, okay, it's not compiler. I guess that, okay, there we go. I guess documentation is pretty good. I'm just bad at reading it. What's this? This is a small vector of resources. You know what? Oh, yeah, I'm pretty sure. Yeah, this is just, it's the same thing here. It's this thing. Okay. Yeah, so if this is a vertex shader, then, oh, actually, I'm stupid. I don't need to do any of this. If stage info.stage. There we go. Because I'm already doing that up here in the compiler. And then am I doing that? Yes. Oh, yeah, I can do it like that. Yeah, I should have just done this anyway. Whatever. So resource dot name ID, type ID, base type ID. So I think like base type ID would just be float, and I think type ID is where I'd get like yeah, the type ID. Okay, well that's images. Oh, hold on, it's off screen. Struct member reflection, reflecting blocks. Yeah, so base type is like float or something, right? It's not like vec3. For vectors and matrices, look at type vec size in columns 1. One column means it's a vector. Okay, so I just want like vec size 2 or 3 basically. So spear type vec size, spear type. So yeah, I think what am I doing? Up here somewhere. where am I getting the types? No, I think, what am I doing? Push constants. Samplers, push constant. Here we go. Yeah, so spear type. Okay, so I am doing base type ID. I don't think I want to do that here, right? I think this is just type ID. And I can say type dot vex size. There we go. So, and these should, I'm just going to assume these are all like float vectors, and so I only care about the size. Yeah, so no, not there. Where's it in draw? Yeah. So this whole vertex mess here. Yeah, 0. Why is that even? Okay, yeah, if I want. Oh. Yeah. What this is doing here, I guess that's fine. Yeah, I can leave that alone. I can just pull this stuff out. This is, so the reason I have this vertex thing here is for, checking, some models don't have indices associated with their vertices. And this is for generating indices and vertices, right? That's why, and I also have this hash down here. That's what this is for. I think that's in Vulkan tutorial. It might be in VK Guide, I don't remember. But this is stuff I care about here. So really, I just want to rip that out. So I shouldn't even be using these anymore. So now, yeah, I guess I just want to, I'll add a binding description and some attribute descriptions to the shader. So here's the binding description. Yeah, just undo that, whatever. And then attribute description. So this will actually be a vector of these. Or, yeah, just take that. We're going to be vector of size, I don't care, called attribute descriptions. And then, yeah, so for every type, get the vex size. And so I want to say, or these should be underscore, since I'm going to have like const getters or whatever for this. Attribute descriptions dot push back. I guess I'll say bk vertex input attribute description then description dot binding. Okay, so I need like all this stuff. And then this is like pushback description. Just becomes description of 0, or yeah, not even of 0. Okay, yeah, binding location format. So I'm gonna need let's put this here. Auto or size to format. I feel like I have this defined somewhere else. I'm not sure. So this is just gonna take in a size t vex size. And switch vex size. Did I do switch? I don't remember. Case 2, case 3, default, whatever, break. There we go. Close that up. There we go. So case 2 is return VK format R32. It's this, but 2 instead of 3. R32, G32, I think. Yeah, I actually don't need break. I'm just doing return. Yeah, that's right. Yeah, it's right up here. Yeah, R32, G32. And then this one is return this. Get rid of that. And default, I'm just going to throw runtime error and say unsupported. Unsupported vertex attribute size plus toString vex size. There we go. This is fine for now. It's basically just like a fix me error to do. So now format is size to format type vex size. There we go. Offset. Yeah, so I want to keep track of offset. So let's say size t offset equals 0. So offset equals offset, and then offset plus equals, actually, yeah, I won't do that. Yeah, I need to do this. Yeah, offset plus equals type dot vex size. Does that make sense? Yes, that makes sense. Okay. Put that down. And push back the description. There we go. Okay, and then so binding location. So ideally, I'd actually get the location. I think is binding always 0. I'm not sure about that. I'm gonna assume that these iterate in location order. So I can just do like location plus plus, and that's fine. These might be in the wrong order. I would think they're going to be in the same order, but I don't know. Or yeah, how does this work? Like, do I specify location? Okay. Well, yeah, hold on. Let me see if I can explicitly get location. Just because if they are out of order, I'd like to handle that well instead of just like silently failing a year down the line. Be like, whoa, what's going on? How do I get? See, like location, decoration location. Okay, well, how do I get that? How am I getting descriptor sets? Yep, here. Okay, it's get decoration. Okay. So location is gonna equal comp get decoration resource dot id decoration location. There we go. That's better. Binding. Guess I can also just say this, right? Decoration binding. Sweet. Okay, that should work. And so if it's a vertex shader, then just create this for me. All right. And then binding description. So when this is done, oh, okay. Now I'm going to assume that these are all binding 0 for now. Because otherwise I have to deal with like sorting between different bindings, and it's annoying. So I will silently fail if there's more bindings. Handle non-zero bindings. Binding numbers. Because I just want this to work instead of trying to deal with all that. So then binding description, binding equals 0, and then binding description dot stride equals offset. Yeah, that makes sense. And then input rate, I assume this is always vertex. I don't really know what this is. I'll probably look it up, but I'm just gonna copy and paste. Well, let me see. What are the options? BK vertex input rate, or can I do so I'll just look it up, whatever. That's the best thing to do. Okay, vertex input rate. vertex instance. Vertex attribute addressing functions of an instance index. Neat. Anyway, it's always vertex for now. Size to format, non-void lambda. Okay. I mean, this is a runtime error. You should not care. Okay, it's just Clang being stupid. Because it should be able to tell that this is a runtime error, but whatever. Just another warning that I can't fix because it's Clang bad, I guess. Yeah, so there's all that. And then I want to go to pipeline. So yeah, I have binding description. Yeah. So load shaders for path. So that means I know that, what is it? Shaders of 0 should be my vertex shader. And then, yeah, I can just say like binding description, attribute description. P vertex binding descriptions. Text. Description count. Well, first I just need to like, okay. Let's copy paste these. Const reference. Const return underscore binding description. And then this is a const reference. Attribute description, const return, attribute descriptions. Okay, and then it should be binding description. Yes. Yeah, so it just has one for now. So does this work? Can this be a const reference, or do I have to like copy this or something? No, that's fine. Okay. Yeah, and same thing for attribute descriptions. So this is shader. Attribute. Description. I guess this should be S. Descriptions. Yeah. And then shaders. Attribute descriptions. Data. Yeah. Okay. Let's see what that does. Now this might have some problems because I think in like the other shader, I'm not, what is this in draw? Draw is not happy with me because I just like renamed it or something. Right, but like I think in the vertex shader, like I don't know if I'm doing anything with these tangents, and also these are vec4s, so I should actually crash. Oh, what is going on? New vertex in model. It's not happy with me renaming that. I wish the LSP rename refactor thing would save all the files, especially if they're unedited. Model HPP in here. Scroll through, but it's just so much. It's such a mess. Okay, and so I actually should crash here with telling me like vec4 is not found or something. So, apparently not. Ugh. Alignment of 4, alignment of attribute address is not aligned in attribute descriptions where attribute address is plus binding stride 3. Oh, right. That's, yep. Shader. So stride is, no. Yeah, that should be fine. What's going on? That's vec size. Oh, right. It's times size of float. Yeah. Right? Offset. Maybe, no, I think. Yeah, this should be size of float here, and then not this here. But this should have It should have crashed unless if like this tangent got optimized out or something. Am I using tangent? No, okay, this must got optimized out. I'm just gonna, yeah, I'm gonna comment that out. Okay. Warning, control reaches in, yeah, whatever. Hey, that looks pretty good now. So that was it. So now we've got actual boxes around everything for the most part. So like this doesn't have a box around it. And maybe like this is supposed to be its box. So there's still some issues with where I'm actually putting the boxes. Yeah. But anyway, this is definitely a step in the right direction. But like this is still red, but it's supposed to be green. Like if it's red, then it shouldn't be getting drawn, is the thing. Right? Why are some of them green? Yeah, that's what I don't understand, right? So like it should show up as green if I'm drawing it. It should show up as red if I'm not drawing it. But then like this is red and I'm still drawing it. So yeah, it's definitely a problem. Yeah. Now it might just be I'm like getting the wrong visible instance numbers or something for these, right? So it's not actually that it's like drawing it when it's not supposed to. It's just like my debug wire. I'm getting the wrong instance state or something. So none of them should be red. Yeah, ideally everything I would see would be green. Yeah, because they'd be off screen. Yeah. And so like that's the goal, is everything I see would be green. But if it's red, then that means there's a problem. Yeah. And then this would also let me do something like later on I could add like a second camera, but then still do the frustum culling based on the first camera. And so like I could still move around and see like what actually gets culled in that field of view. I do cool stuff like that. But for the moment, I want to actually get this working right. But this is definitely like made a lot of good progress today. Yeah, neat. Man, I like just running around in this. Now, yeah, me running around in this like this probably destroys the compression. I'm not sure how bad does this look on Twitch, because like I'm using H.264 on Twitch because it won't let me use AV1. So on YouTube it probably looks somewhat okay because I'm doing like 30,000 kilobyte a second AV1 or something. So probably looks okay-ish on YouTube. Or no, I think YouTube actually transcodes back down to like VC1 or something stupid like that. So I don't know. Yeah, this probably looks awful on Twitch. But anyway. Yeah. Yeah, and it's weird, right? Like it's just kind of like sporadically green. I would think like I just have like big chunks of green. And so that makes me think this isn't like the culling algorithm. This is like the I'm not like setting the right colors on the right boxes or something. And then also, I'll just reload it because that's faster than walking all the way over there, running at least. And then also like this chessboard here, this doesn't have a box around it. So I'm doing something wrong with that. That's also something to fix. Right, and then animations just straight up don't really work with this right now. But all I need to do there is adjust the OBB by the animation. So that's fine. But okay. Yeah, so I made a lot of progress today. Let's see. So what else do I want to do? So I want to fix the frustum culling first. I want to add timestamp queries so I can see like how long the frustum culling and drawing the box and stuff is taking. Is that it? But before I like actually merge the rewrite. Yeah, I think that's it before I merge the rewrite. And then I want to probably redo the render graph again. And put it like back to the old system. And then, Oh, right. And then once I redo the render graph, I want to try to do automatic synchronization. So right now I have to manually specify these memory barriers everywhere. Um, but once I redo things, so part of the problem why I can't do it now is because I'm losing the it's basically impossible to like pull. So what I need for the synchronization is I need to know which buffers that shaders are reading to or writing from. But it's pretty much impossible to do that with this like anonymous lambda stuff because like the whole point of this is kind of to abstract out some of those like fine details. But I need those. So I have to go back to the old system if I want to do automatic synchronization, unless I do like something crazy with adding more parameters here for synchronization. This is terrible. Or yeah, like I can read from the shaders, I guess. But then that like, yes, so I do want to read from the shaders. But then stuff like I'm doing somewhere in here I'm doing like yeah, fill a buffer with zeros, right? So I'm like zeroing out the count, the cold draw indirect count before I like start incrementing it again, right? And so stuff like this doesn't work. The automatic synchronization was the whole point of render graphs. Yeah, that's a big part of it. And so the way I have the render graph set up now, it's kind of difficult to do automatic synchronization. I think I can still do it. I can do it, a lot of it, by checking the by doing shader reflection. So I can look at here and see, okay, these are read-only buffers. Well, so then this shader doesn't write anything; it just reads stuff, or yeah, I mean, it'll write something, right? This will write to like a color attachment. So I can look at the shader and I can see, okay, it's reading from all these buffers and it's writing to the color attachment. So then anything that writes to these buffers before this thing runs, then I need to have a barrier to make sure that those finish. And then anything that reads from the color attachment after this runs, then I can put a barrier there. So I can't figure it out, but then that only works for shader stuff. It doesn't work for things like how do you know which buffers will be bound? How this works is I'm not quite sure why like this piece exists here. Right, like I have instances, and then I actually have like the type of the buffer, and then like a variable here. It's kind of verbose, but anyway, I'm taking whatever this name is here, the name of the buffer, and I'm like pulling that out with the shader reflection stuff, and then so like how I'm defining the buffers is I can just say, oh, like I can give it the same name, and then the buffer. So I gave the buffer a name on the CPU, and this is like a GPU buffer, but the name is in C++, right? And then so the GPU buffer that's named this will get automatically bound to anything in the shader that's named this. So like instances or whatever. And so that's how I know which buffers will be bound, is because I can look at these names here and I can tie it back to an actual buffer in my allocators. Yeah, there's only ever one. Currently, all of these names need to be globally unique. Yeah, and I don't think GLSL has support for really doing like namespaces or something. So like, yes. So if I wanted to like non-globally unique stuff, it's not great. But that's just kind of a downside of GLSL. I don't think there's much I can really do about that, right? So like if I make this more dynamic so that like a lot of like if other people want to like start adding custom shaders and stuff and you want to like pull custom shaders from multiple different people and stuff like that, what I'll probably have is just like a standard naming convention of these buffer names. So you'd say like, oh, this is like your mod name or something, and then you can have like, so you'd say like, okay, you'd say like mod name, and then I don't know, maybe this is your, and you could just have like the buffer like that, or you say like mod name custom namespace instances, something like that, so that you don't run into conflicts if you're like trying to pull shaders from like multiple different people or something. But that's way far in the future once I actually have a working game engine that people can use. But for now, like just having basic globally unique buffers is perfectly fine. Yeah, and so that makes it really easy to like use different buffers between different shaders, right? So like I just have visibility buffer here, and then I also have it here, and like these are always going to be the same buffer. So it's pretty nice. Yeah, and then I have like read only and write only, stuff like that. And then I don't know if Vulkan lets me like, I don't think so. I don't think I can say like, give me a barrier on this specific buffer, because like ideally I'd put like a read barrier on this buffer and a read barrier on this buffer and then a write barrier on this buffer. But I don't think you can do that. Maybe there's something with like synchronization too, but I don't think so. Yeah, so all the shaders will probably just have to be like read and write barriers, except for I guess like the vertex shader that can be like read only and then write to color attachment, but whatever. But anyway, this is pretty neat. I've got a lot of progress done today in the last 5 hours. Yeah, I think this is my longest continuous stream so far. It's a little over 5 hours. So I'm gonna get off for the night. I will be back tomorrow morning. I think I said 9 a.m. or 10 a.m. Central Time. I don't remember. But I'll be back tomorrow morning. Yeah. So, see ya.